Yes, good afternoon, everyone. We're on the afternoon session of our 10th workshop on computation theory and practice. So this afternoon, we are privileged to have an invited speaker. Our moderator for the invited session is Dr. Raymond Sison, professor at the Salle University. Raymond, thank you. Glad to see you again after a long time. So, are you already unmuted? Raymond, you may. So, may introduce Professor Murata. Oh, sorry, we cannot hear you, Raymond. You're not muted, but we cannot hear your voice.
Can you hear me now?
Oh, yes. Okay, thank you.
Okay, there. So good afternoon once again, everyone. It is my pleasure to have Professor Tsuyoshi Murata as our invited speaker today. Professor Murata was with me 20 or so years ago at the laboratory of Professor Masamichi Shimura of Tokyo Institute of Technology, and Professor Masayuki Numa was also in that same lab. That was a long time ago. And now Professor Tsuyoshi Murata is a full professor at the Tokyo Institute of Technology. Ladies and gentlemen, let us welcome him as he gives us his invited speaker talk.
Thank you very much for the introduction. So I will share the screen now. Oh, sorry. Can you see the screen and can you hear my voice?
Yes, we can.
Okay. So yeah, thank you very much for the introduction. My name is Tsuyoshi Murata from Tokyo Institute of Technology. And I would like to talk about this topic, networks, deep learning, and COVID-19. So I'm very glad to be here. So yeah, and first of all, let me briefly introduce myself. My name is Tsuyoshi Murata, and I'm a professor of the Department of Computer Science in Tokyo Institute of Technology. And my research is about the artificial intelligence, especially network science and the machine learning. And recently, we are doing graph neural networks and the classification or prediction of the time series data, such as the prediction of volcanic eruptions. So I go to the laboratories of the volcanoes and sometimes make a discussion. And I did, I'm also doing a social network analysis. And this is the website of our lab. And today's slides will be available from this website. I'm afraid to say that I don't know much about Philippines, and I still haven't been to Manila. But I know one Filipino student, and he's very excellent, and he worked very hard and published many papers with Professor Shimura, Masamichi Shimura, and Professor Masayuki Numao. They were my boss when I was young. And the student wrote the papers in a prestigious journal such as Machine Learning. And now he's the dean of the Salle University. So yeah.
You're the one introducing me.
Yeah, he's very big. And but yeah, I feel relieved that his face is almost the same as we met more than 20 years ago.
You too, Professor.
Thank you. And today's talk is not about Professor Raymond Sison, but this is the table of contents today. So yeah, the first topic is about the networks or graphs. I'm interested in networks and doing analysis, doing research on graphs or networks. And recently, the deep learning is very popular in the field of artificial intelligence. So we are doing research how we can combine the networks plus deep learning. And recently, COVID-19 is very popular worldwide. So we are thinking how we can do by combining networks plus deep learning plus COVID-19. So this is the contents today. First, I'll talk about the networks. As you know, the networks or graphs is a set of vertices and edges. So yeah, and I often use the word graph and networks interchangeably. Yeah, there's no clear difference between these two words. So I will use these words interchangeably in this talk. And many objects in physical, biological, and social sciences can be thought of as networks. Yeah, this is the social networks of Facebook, and this is a metabolic network, and this is a food web. Yeah, which insect was eaten by which animal or bird, and so on. So the relations of the animals can be expressed as networks. So by studying the structures or the properties of the network is very important, and it will give impact to the several research fields. That's why I'm doing research of networks. And in order to understand and analyze networks, we have to study many things, such as metrics, algorithms, and the models, and the processes. Yeah, in order to explain each of these concepts in detail, such as path length, density, diameter, degree distribution, clustering coefficient, is the main topic of the metrics. And many algorithms of graphs, such as Dijkstra's algorithm, graph partitioning, and the centrality computation. And there are several models for generating graphs, such as random network and scale-free network, and so on. And the process is to analyze the behavior on a network, such as rumor, disease diffusion, and the influence maximization, and the SI model, and so on. So we have to learn many things. And that's the topic we are doing right now. And these are the topics, such as, what kind of groups can be found in a network? Yeah, these groups are called as communities. So this is the example of communities, but the definition of communities is very controversial. Yeah, so there are so many topics and so many methods for finding communities. And another topic is link prediction. So probably you will find, you will be recommended by the social media. This person can be a friend of you, and so on. And such kind of recommendation, friendship recommendation, can be done by using link prediction. And the centrality and the ranking is another important topic of analyzing graphs. And the influence maximization, is the very hot topic in the in this situation of COVID-19. And then the networks are not so simple. It can be huge, it can be incomplete, it can be noisy, it can be directed, weighted, signed, temporal. So there are several variations of the networks. So we have many things to do in order to do these tasks. This is some of the examples that we did for the network analysis, such as community detection in sign network. Sign network is composed of friendship and enemies. So the red lines are friendship, and blue dotted lines are enemies. So the groups or communities should contain more and more red edges and less blue edges. So detecting this type of sign network is sometimes not so easy. And if we did some kind of detection, we can sometimes detect the nested communities. In a big groups, there are small groups that hate each other. So that is the this type of communities can be found in especially in the political parties in Japan. I have no idea how the political situation in Philippines, but it sometimes happen in human societies. And this is another topic, transductive classification of heterogeneous network. So suppose this blue person is a researcher of database, and he wrote the paper of the database, and he presented at the conference of the database. And the red person is a researcher of AI, and he wrote a paper of AI and published at the AI conference. But the white person is not known. So the this classification is to put the labels to each of the white nodes, which are the database researchers and which are the AI researchers and so on. So Peter did, he is from Thailand, and he did a very good job, and published the paper in a very prestigious conference. Wisdom is a very good conference in the field of data mining. And influence maximization in dynamic network is important for viral marketing, for promoting something. So finding a set of nodes that will propagate information most in given social networks. That is the topic that we study for information diffusion. And the opposite situation is how we can prevent the disease spread. So this type of topic is very popular in the field of network science. And detecting communities in distant members. So Liu Xin, he is a student from China, and he did a very good job for detecting the communities that are living far apart. If we detect communities, the people living nearby will be grouped together often. But this method can detect the communities that are located far apart. So that method was used by the researchers of US Military Academy in order to detect the terrorist network. Of course, we do not have the data of the terrorists. So we have invented a method, and the US Military Academy used this method and use their data in order to detect the terrorist network. That is the topic. That are rather old topic. But it is interesting that our work is cited by somebody else. And if you want to study more about the network science, this book is a very important textbook. So you can read it. But this book is very thick, more than 500 pages or 600 pages. But it is worth reading. Okay, so this is the first topic. And recently, deep learning is a very hot topic. So we think how we can combine the networks and the deep learning. As you know, the deep learning is very powerful in several fields, such as image recognition and the voice recognition and the natural language processing. So yeah, it is a neural network composed of many layers and many parameters so that it can learn for the image recognition and the natural language processing. So yeah, and the study of deep learning is very hot recently. And yeah, the main player in the deep learning is a convolutional neural network. So probably, yeah, some of you know, yeah, the task of detecting numbers or digits, these pictures, whether this picture is a number 0 or number 1 or number 2 or number 9. So yeah, the convolutional neural network is to recognize the local features, yeah, within these small squares. And then these features are hierarchically structures. So the it can recognize from local features to global features. Then, yeah, this convolutional neural network can detect that this digit is number 2. But the convolution for the images is rather easy because the pixels are, yeah, very, yeah, structurally simple. It is a grid of pixels. And in the sentences, natural language processing, the words are the, yeah, sequence. So the, yeah, just arranged in a line. So the structure of the pixels and the words are rather simple. But how about the networks? The number of neighbors is not fixed and topologically very complex, and the vertices are not ordered. So the convolution for networks or graphs is not so simple compared with the images and the sentences. So we have to do, yeah, research for doing convolution on networks. So the graph neural network is a very recent topic for learning, yeah, deep learning using, yeah, graph structures. So this is a learning features of vertices using their neighbors. So suppose, yeah, this is a social network. Yeah, this circle is a person, and yeah, some of them are, yeah, Republicans, and some of them are, yeah, Democrats. So I forgot which is which, but anyway, yeah, some of, yeah, and the center person is not known whether he or she is a Democrat or Republicans. So in order to, yeah, detect whether, yeah, he or she is a Republican or Democrat, yeah, graph neural network can be used in order to learn the features of vertices, this node, using their neighbors. So the graph neural network is a, yeah, neural network in order to learn the features of the central node by using the features of the surrounding neighbors. And then after the learning, we can do some classification of the center node, whether he's a, yeah, Republican or Democrats. So this is a very, yeah, simple explanation of the graph neural network. And there are several variations of the graph neural network. And yeah, the time is too short in order to explain it in detail. So if I have, yeah, 3 hours, then I can explain in detail. But I have only 30 minutes. So yeah, I will skip here. And this is the, yeah, popular machine learning tasks such as classification and the regression. Regression is to predict the number based on the input data. And the clustering is to find the groups. And the dimensionality reduction is to, yeah, find the, yeah, important dimensions exist in the data. But in the case of graphs, the tasks are rather different, such as classifying nodes and classifying graphs and predicting some links and thinking of some models for generating graphs. Yeah, these are the popular tasks for the graphs in the field of machine learning. And yeah, this is the application of the graph neural network. So yeah, it can be applicable for several fields such as computer vision. Yeah, in order to understand the complicated pictures, yeah, it is not so easy just from the images. So for example, the surfer on the ocean is on a surfboard, and some part of the body is in the sea, and some part is visible, and some part was not visible. So in that case, if you take a photo of such surfer, then only a part of the bodies can be detected. But we know that the full body exists, and some are not visible at that images. So we have to understand the structures of the bodies of the humans and understand what is it in figures or pictures. And graph neural network can be used for the recommendation systems and the traffic prediction and the chemistry, such as some kind of molecular graphs are toxic or not, or soluble or not, soluble to water or not. And this is the article that is published by DeepMind only 2 months ago. So they are doing traffic prediction with advanced graph neural network. So if you're interested, you can check this article. The essence is to segment road as graphs. And then some features, for example, the surrounding environment of each part of the road are represented as features. And then graph neural network is used in order to predict the traffic jam, or how many hours it will take for going through this part of the road. So this is idea, and they collaborated with Google in order to get some data, and according to that announcement, they succeeded in making traffic prediction accurately. And we are also doing research of the networks plus deep learning. He's a student from Malaysia, and he did a community detection using a variational autoencoder. So this is some type of deep learning module, and he invented the deep learning method for the networks, and published the papers of the ICDM conference, which is a very prestigious conference in the data mining. He graduated the PhD course, and now he is working in Japan. Because he cannot go back to his country right now because of COVID-19. And this student is from India, and he invented a new graph neural network in order to approximate the betweenness centrality. So I have no time to explain in detail, but he published a paper at the CIKM conference. And she's a student from Kazakhstan, and she is doing a research of graph neural network for detecting brain disorders such as Alzheimer's disease. So the input is a fMRI data, is a brainwave data. And based on that data, the brain network is used. Brain network is created. But it is only for one patient. And there are several patients of similar symptoms. So the network of the brain network will be used in order to detect the brain disorders. And she used the rather simplified graph neural network in order to detect whether brain disorder is exists or not. And if you're interested in a graph neural network, you can check the tutorials of Triple AI 2020. So you can check here. And the last part, how many minutes do I have? 5 minutes?
Yes, 5.
Okay, I was so quick. So the last part is networks plus deep learning plus COVID-19. But this part should be divided into networks plus COVID-19. So I will first talk about it. And network is important tool for analyzing and modeling epidemics. Yeah, because the disease spread in the social networks. So some people are healthy and get sick, and he or she will be recovered or dead. So this is a Japanese traditional ghost. And in order to analyze these behaviors, the network structure is important, and the probabilities of infection, and the number of infected people, and the probability of recovery is also important. So these are the parameters in order to control the epidemics. So SIR model is a very simplified model for the disease epidemics. S is healthy, and I is infected, and R is recovered or removed. So if you use this type of Python library, you can draw this type of graph expressing the number of susceptible, number of infected, and number recovered. So this is a simple demonstrations. And if you like mathematics, you can study in detail. In a very detailed differential equation will appears. And if you solve this equation, this equation is not easily solved, because S appears here and the exponent here. So this should be solved numerically. So this will be the discussion. So I have no time to discuss in detail, but some mathematical background exists for the epidemics of networks. And recently, after the pandemic of COVID-19, so this is the paper in April in order to model the COVID-19 epidemic in Italy. So they propose SIDARTHE model. SIR model has 3 states, but this model have 1, 2, 3, 4, 5, 6, 7, 8 states in order to explain the situation of epidemic in detail. This is a not diagnosed patient, and this is a diagnosed patient. These should be separated. And if you think more and more complicated models, it can explain more complicated situations. And the researchers says that this model fits to the data of Italy this year. And this is another paper in order to evaluate the power law curve between countries. So this is the curve of which country? USA, France, Brazil, Germany, Italy, and so on. So the curve of the number of patients are rather similar, according to their analysis. And they follow the power law this formula. And so this indicates that the events happened in other countries is often happen in our countries. So we have to study from other countries. So that is the meaning of this paper. And there are some other papers, such as the effect of travel restriction of Wuhan, China, will be effective for preventing COVID-19 outside of China or inside China. It was effective for preventing outside of China, but COVID-19 was already diffused, so it was not effective inside of China. And this is the analysis of genomes of the COVID-19. So phylogenetics. I'm not so familiar with the concept of the life science, but this is for the inference for the evolutionary history of the relationship among group of organisms. So this paper analyzes the variation of the COVID-19 genomes. So this genome is from East Asia, and these genomes are from Europe and America. So this type of analysis is important to analyze the mutation of the COVID-19 and evaluate which vaccine will be effective for which countries. So this type of studies is done and published in this year. So we don't have enough time. So this last topic is about the network plus deep learning and the COVID-19. So you can check the website of the graph representation learning and beyond. So this is a workshop collocated with the ICML conference. So this is the workshop of the researchers of graph neural network, how it can be applied in the situation of COVID-19. So how the machine learning method can be used for the COVID-19 responses. So in order to do some tasks, biomedical treatment data and the epidemiological data and the supply chain data, they are very heterogeneous and the graph structures. So these type of tasks are necessary in computational drug design. How we can design a drug for COVID-19, and how we can use the medicine that are already appeared in already exist for COVID-19, and how the disease will propagate it in the social network, and how the supply chain will be controlled, and how the patient epidemic will be tracked or traced. So I have no time to explain it in detail. So if you are interested, you can check the website of the this workshop. Okay. So, and I wrote a Japanese article regarding the COVID-19 and networks. So if you can read Japanese, I will send it to you. So please give me an email. And I'm writing an English version, right now. And this is a topics that I talked today. So thank you very much for listening. And the slides are available from here. Thank you.
Thank you very much, Professor Morata. We look forward to your English version of the Japanese article. So do we have any questions from the audience about Professor Morata's presentation?
Raymond, Yami here. I have a question for Professor Morata. Thank you very much for your presentation. That's really very interesting and tells us where to move in relation to advancement in machine learning. I'm curious about where you get the data that you represent as graphs. And then later on, you just have the typical graph representation you put into your neural network. But where do you get the data set?
Yeah, the data set is for the COVID-19, you're asking?
For graph networks in general.
Yeah, there are some data sets that are very popular in the field of machine learning researchers. So wait a moment. Can I search? Yeah, I can search. Wait a moment.
Okay, thank you.
Yeah, I can find it very soon in my computer. Where is it? Wait a moment. Uh, uh, yeah. Uh, hmm. So this is yeah, I found it. So how can I share the screen now? Sorry. Okay. Which one? Yeah. Can you see this screen?
Yes.
Yes, we can.
Open Graph Benchmark is a site for the data set, benchmark data set, data loader, and the evaluator for the graph machine learning. So
Okay.
you can check website. This website. This is the site by the Stanford University. So you can check. Probably popular data set can be available from here.
Okay, thank you very much. This is helpful for us to at least have something to play with. Thank you.
Okay, you're
Thank
welcome.
you. We have time for one more question. Okay, so I have a question, Professor Murata. You mentioned in your abstract that there are many challenges in using graph neural networks in real world, in solving real world problems. So if you would rank the challenges, what would be number one?
So the the recent topics of the graph neural network is mainly for the classification. So how the classification accuracy should be increased
Okay.
by using graph neural network or not. But I am rather interested in what we can do with how far we could go with the neural network. So some tasks can be done accurately by using a neural network, but some tasks are not so good by neural networks. So probably this is related to the history of the AI. So some researchers loves the symbol representation, and some are pattern representation, and the neural network is a pattern for the pattern representation. So I'm rather interested in how far we could go based on pattern methods. So it may not be a good answer to your question, but I'm interested in the graph neural network and how far we could go with the neural networks.
So do you also try to compare graph neural networks against a simpler approach to, for example, classification of complex problems?
So this is the topic, and we and our students are also doing but the graph neural network is a rather very hot topic, and this many papers appeared in that field. So many students dive in that field, but know that both fields are rather important, and how we can combine these two approaches.
Right. Okay, it is exactly 1:40. Time to move on to the next paper. We thank you very much, Professor Tsuyoshi Murata, for this enlightening and encouraging discussion on graph neural networks and how they can be used to solve problems including COVID-19. Thank you very much. Thank you very much also to the audience.
Thank you.
Thank you. Thank you. Yes. So for this afternoon session, uh, we will have a series of papers presented. Each one will be given 25 minutes, including Q&A. So please reserve around 3 to 5 minutes for Q&A. So you're given 20 to 22 minutes for your talks. So the first talk is entitled Effect of Parameters and Clustering Algorithms on Interaction-Based Community Detection in Twitter by Ryan Austin Fernandez and his co-presenters. Yes, please unmute yourself and share your screen. Ryan Austin.
Good afternoon. Hello. Thank you for the introduction. So good afternoon to everybody. I am Mr. Austin Fernandez, here to present our study. So here's a brief outline of my presentation. Okay. So to give a quick background for the study, let me just give you a refresher. So today we often have social media at the back of our minds, Facebook, Twitter, Instagram, and social networks are really, to put it simply, it's a dedicated website or other application that enables users to communicate with one another by posting information, comments, messages, images, etc. And by the very nature of social networks, this kind of application lives and thrives on user interaction. There could be no social network, given, of course, the name, a social network, without users actually interacting with one another. One such social network that is very popular today is Twitter. And just for some brief statistics, for Twitter, there's 347,000 tweets sent every minute, 4 million posts liked in Facebook, at least. And for Instagram, there's 2 million posts liked. For YouTube, there's about 300, 300 hours worth of videos on YouTube uploaded every minute. This tells us that there's a lot of data and a lot of information that could be extracted and processed from these social media websites. And now to proceed with the next part, let's focus down on Twitter for now. In Twitter alone, there are several interactions between users, several types. There's following, so users can follow one another, so that if you follow, it's a directed graph. You can see that person's posts. Sometimes you see their likes and their retweets. You can like their posts, which means if they post something, you are expressing your quote unquote approval for what they just posted. There's also retweeting, which is someone posts something and you want to share it on your own timeline. So that's another interaction. There's, of course, replying. You can reply to someone by continuing the discussion based on their initial post, or reply to someone. So you're going down further the rabbit hole. There's also mentioning. So you can mention other users directly in your tweets. And there's the hashtag, which is you're sort of joining a conversation regarding a particular topic that may or may not be trending. For example, a current TV show or a current political issue. A few weeks ago, there was the elections in the United States, of course. That was trending for that week. Topics like that, you can join a conversation by using what you call a hashtag, which is represented by the sharp sign over here. These interactions are really the crux of Twitter's network structure. It's how users interact with one another, and it's how you can define interactions between these users. So really, if you choose any one of these interactions, for us computer scientists, you get what we know as a graph. If we represent our users as vertices in a graph, then these interactions will define edges. And if based on how I define the interactions, these edges are directed edges, right? So you mentioned someone, that doesn't imply they mentioned you back. And if you put all these people in this network or graph structure, there now starts to form what we would be defining as communities. Communities are essentially groups of users that have more in common within their own communities than those outside of their communities. So for example, in this figure on the screen right now, you could say that the dark blue people are much, we could define them as a community. They have more in common with the other dark blue nodes than they do with, for example, the orange nodes. However, this is just an example of a generated set of communities. As you can see, there are some odd choices, such as the one on the far right. It's a blue node very far from the other dark blue nodes. Which begs the question, community detection is not exactly always going to result in the same set of communities. There are several considerations to make, such as the what we define as the hyperparameters of a community detection system. These hyperparameters that we'll be focusing on for this study are your community detection algorithm, basically how do you actually form the communities, and your similarity parameter, which is how do you define our edges. Like I mentioned, there are several interactions in a social network. So defining the edges is actually a very crucial part to even just defining your network. And without your network, you can't detect communities. So those two hyperparameters, honestly, currently in the literature, the studies focus on specific properties in a certain form of community. Sometimes it's Twitter, like the work of Zhang from 2012. There's other works. And typically they fix one or more of these hyperparameters. They use a specific algorithm or a specific edge definition or a similarity parameter. Our study intends to actually explore the variability of these two. It's going to bring us to our main research question, which we're trying to answer with this study. How do different combinations of community detection algorithms and similarity parameters affect the trends and structures in the communities detected in the social network? So to do this, I would like to first go over how we actually represented our data. So as previously mentioned, our network is represented as a graph. So the users are the vertices, and each vertex has the following attributes. They have the user ID. That means we anonymize the data we've collected using the TweePy API. And we also have a following network, so which users follow which, essentially. And we also have a list of user tweets. For the tweets, we maintain the text and the entities inside the text. So that includes hashtags used and mentions. Also retweet status, so which users retweeted this particular tweet. Okay. This all is how we define our data, our network. And through this data alone, we are actually able to define our similarity parameters. So for this study, we scoped down to the following algorithms, parameters, and evaluation metrics. So there's the classical k-means clustering. This is a pretty common clustering algorithm. I won't go too deep into it. The others may be familiar, but maybe I haven't heard of them in a while, so I'll go over them briefly. There's divisive hierarchical clustering and agglomerative hierarchical clustering. These two are almost symmetric to one another. Divisive works as you put all the users in one community and you sort of split them to maximize the modularity. Usually you can do this with a two-means clustering algorithm. And you continue to split the communities until you've reached maximal modularity. So the communities you form, you just keep splitting them. Agglomerative works the other way. You start each user in their own individual community, and you start merging them in a greedy fashion as long as it maximizes the increase in your modularity. So I'm mentioning modularity. In simplest terms, modularity is a measure of how much better are the formed communities compared to randomly generated ones. If you just roll dice to generate your communities, that probably won't be good. And there's the paper we used, which is from Newman's formula. It's modularity indicates how much better is your community, the communities you detected compared to randomly generated ones. So that's what we use for divisive and agglomerative. However, for agglomerative, you can choose to stop sort of arbitrarily. So we implemented a version that did not go for the greedy route, as in if merging any of the communities would lower the general modularity of the community set, that would indicate that we're doing a greedy approach, which means we may hit a local optima, and we may not be able to find the global optima. So we have implemented a version of AHC with simulated annealing. So if we hit a local optima, we can allow suboptimal mergings of communities with the hopes that we may reach a more global optima, or at least a relatively higher optima compared to the one we were supposed to stop in with the deterministic algorithm. For our similarity parameters, we limited our networks to following hashtags, retweets, and mentions. Wait, give me a time check. 151. Okay. So these are the 4 versions of the networks we dealt with. We did not consider networks formed by a combination of 2 or more parameters. So each of the networks we experimented on are just networks formed by one form of edge. And our evaluation metrics were modularity, again, as defined in Newman's paper from, and Davies-Boldon index, which is, to put it simply as I could, it's the ratio of the scatteredness of the individual communities against the distance between the communities. So it goes back to our main definition of communities, which is groups of users with more in common with one another than they do between other communities. So that is essentially Davies-Boldon index quantifying that definition. It's the measure of scatter, which is typically a Euclidean distance mean, arithmetic mean, divided by the betweenness distance of the communities. So that means a lower Davies-Boldon index is actually a better value. But for modularity, since it's actually a measure of how much better your communities are compared to random communities, the higher the modularity, the better. So they're kind of opposite in that scale. So to describe our experiments, we ran 2 basic experiments to sort of compare these combinations of algorithms and parameters. The first one is run on the Electronic Entertainment Expo dataset. So for this dataset, we collected 250 users for 10 companies. The 10 companies are game development companies, and we mined users who were talking about games from each company. 250 users total, 200 tweets per user. And these tweets were searched by keyword, which were the company names, for example, Naughty Dog or Ubisoft. If they were mentioning games created by these companies, they would be classified under one of the 10 categories. And yeah, 250 users per keyword were obtained. The problems with this were retweets had to be filtered out, and the tweets that were mentioned YouTube were removed because for YouTube, it was generally them linking to one of the trailers that was revealed in the E3 Expo. For the Philippine University's dataset, this one, we formed this dataset because we had an expectation of what communities would be formed, and we wanted to confirm that hypothesis that certain parameters would lead to certain types of communities. For example, following, it's kind of expected for people in the same university to be more likely to follow one another than otherwise. So we picked 5 universities with easy to search for keywords. We tried to add more to this, but we couldn't find keywords that would mine enough users. So we picked these 5 universities. If you notice, UP and UST, we were not able to use those as keywords because apparently if you use them in TweePy, it returns tweets that actually just mention the word up or words with the suffix UST. So we used the Diliman and Tomasian keywords respectively to mine users from those universities. Again, all of the users were anonymized. And these were the 5 largest user bases that we were able to mine that met our quota of 200 users per university. With a total of 200 times 5 universities, that's 1,000 users. And we limited it to 200 tweets per user to form our networks. The problems here were, again, as mentioned, the good keywords could not be found for certain schools. So we were not able to mine those schools. And if we were able to mine consistently users from those schools, we often didn't find enough to reach our quota of 200. So we only limited it to the 5 universities previously mentioned. So now for the results of our experiments. Our experiments were run with all the combinations of algorithms and parameters. So that's 4 times 4, 16 experiments all in all. And we ran 3 iterations of each algorithm, except for agglomerative hierarchical clustering, because that's a deterministic algorithm. So only 1 run was necessary. For the E3 dataset experiment, I would like to present the results in, well, these 2 experiments, our results are kind of different, and you'll see why in a while. For this experiment, all combinations were unable to split the network into more than 1 community. The reasoning for this is because of the underlying the underlying structure of the network. Apparently, mining 250 users from 10 different companies was not exactly, it didn't lead to expected results. What do I mean? People who tend to talk about one company in the E3 Expo, they also tended to talk about the other companies. Usually people aren't quote unquote loyalists to one company. So if they're talking about the next Assassin's Creed game, for example, they would probably talk about the next game by Naughty Dog or EA or the other companies. So mining exclusively for companies was not exactly an ideal way to sort of have an a priori expectation on what communities would be formed. As a result, all of our runs actually just resulted in 1 community because the graph structure was too dense to perform meaningful community detection on. So this experiment was actually not very successful, not successful at all. But for the Philippine University's dataset experiment, we had relatively better results. So here's the table presented differently because now we actually have results to present. On the rows, we have the similarity measures. On the columns, we have the algorithms. And inside the cells, there's the average number of communities per run, which explains the floating point numbers. And following was able to consistently split the data set into multiple communities. Our hypothesis here is that following was able to sort of, this was the center of our hypothesis regarding this data set, that people within universities actually follow one another more likely than they are to follow across universities. It's just because you spend the most time with these people and you tend to follow the people within your circle. So that was sort of confirmed by our experiment because the number of communities were more or less at least 5, which is the number of communities we were expecting in the first place. For hashtags, it was unable to split the dataset using any of the algorithms. This experiment was not successful. For k-means, only following really produced more than 1 community. For k-means, we implemented this by slowly increasing k until modularity was maximized. So we had a range of k values, 1 to 10, and we tried to maximize the value of k, the modularity, according as a function of k. So for following, the maximal modularity we were able to reach was with k equals 4. For the rest, it was actually a single community. That's because, like the E3 dataset, our hypothesis was that the network was too dense using those as edges. But for the divisive hierarchical clustering, following and retweets network actually were able to produce more than 1 community. Following had close to 5 for some of the experiments, but retweeting stuck to around 2 to 3. For classical agglomerative hierarchical clustering, only following produced more than 1 community. It actually produced several, 26. That's way more than we expected. And the combination that consistently produced multiple communities was agglomerative hierarchical clustering with simulated annealing implemented plus the following network. And that led to around 24 to 25 communities consistently across all runs. If we're taking the Davies-Bouldon index, again, this is to explain why there's a lot of non-applicable cells here. Davies-Bouldon index does not apply if you have less than 2 communities. So all these cells with the 1, we were not able to apply the formula. But it resulted, the lowest DBI was 1.355. Okay. The lowest one here is retweeting, actually. But since this one was consistently able to yield multiple communities, we highlight this result. It sort of is the middle ground between the 2 evaluation metrics for communities. General observations about the trends or the patterns. This is the analyzing how these algorithms generally affected the results. There's 2 groups of algorithms. The k-means and DHC generate a small number of communities, but the agglomerative algorithm just generates more communities. And following was the most consistent, reliably generating good communities based on modularity. And it is kind of expected because we had an a priori expectation for the dataset that we used. Mentions and retweets are less effective versions of the following network in terms of being able to generate consistently good communities based on the modularity measures again. Hashtags were able to discover unexpected communities at times. It was usually topical in nature, not based on the following network. That was for the university's dataset. So in conclusion, different combinations generate communities with different qualities as follows. Similarity parameters affect the content of the communities. So it's really the sort of the classification measure between the communities. What communities, how could you describe these communities? You could generally trace it to what similarity parameter was used, but algorithms generally affect the community structure. How dense are they? How many communities are formed, and so on. For recommendations, we recommend, because if you notice, our collection method was kind of haphazard. We had a certain data set or a target audience or for users that we wanted to target. So we mined specific keywords. If we were to use this framework to analyze more properties of communities, perhaps a more standardized data collection method could be used to just pick a topic, and certain keywords can be mined associated with that topic, and the users could be mined in an automated fashion. Also using other algorithms, parameters, and even social networks. So Twitter is one. We could use others like Facebook, or Facebook's kind of difficult because the API at that time. So that's why we didn't consider it. But there's also Instagram right now. And yeah. Also, other parameters, other social networks would have other parameters. And we only dealt with 4 algorithms, so there's plenty of other clustering algorithms out there. For the thresholds, this could be to make the graph less dense. Our graphs were unweighted. So if you followed if you mentioned someone 3 times, that's the same edge as if you mentioned someone once. So perhaps you can put a threshold to the the definition of the edges, so that on edges only formed if you were mentioned at least k times, something like that. And allow stacking of multiple parameters. Like I mentioned earlier, our scope was limited to 1 parameter per graph network. So if we could have edges defined across multiple parameters, that could lead to other possible community structures. Thank you for listening. That is all from me.
Okay, thank you, Ryan. Are there any questions from the panel or the attendees? You might want to type your questions on the Q&A tab. We will be entertaining 1 or 2 questions. Again, thank you, Ryan. I think we'll be proceeding to the next. The next speaker will be paper of Adrian Charles Mendoza and others, entitled Gate Abnormality Detection Using Multimodal Sensors and Machine Learning. You may start.
Hello?
Yes, we can hear you.
Okay, very good. Thank you. So I'm Fritz Flores. I'll be presenting on behalf of my students for, again, the gate abnormality detection using multimodal sensors and machine learning. So the outline of the presentation would be introduction, methodology, data collection, machine learning, results and analysis, and conclusion and recommendation. So to start off, gait is essentially the study of locomotion. So in this case, for human locomotion, it starts with the heel from the reference leg striking on the ground up to the point that the same reference leg strikes down at the ground again. So that is essentially one gait cycle, showing the locomotion on how a person walks or moves. So in a normal gait, essentially the person is stable and flexible while maintaining energy efficiency as he or she is walking or moving. But for abnormal gait, so this is when a person's walk does not function in a normal way, such as in these two examples, we have antalgic and neuropathic gait. So gait analysis is essentially a study to be able to determine, again, a human locomotion, if it is normal or abnormal. It can also be used to determine the identity of a person because it is said that each person's gait is different from another person based on essentially the factors and characteristics that they have obtained throughout essentially their lives, no? Changing how they move. In this study, there are multiple works that have implemented gait analysis with different kinds of equipments used to analyze gait. First of which are through vision sensors, such as through smartphones, which are typically used by medical professionals to see if a patient has some gait abnormality. Another technique of researchers is to use Kinect to obtain 3D body joints as well as the angles and shape of the skeletal structure of a person as he or she would be walking through an area. So to summarize these technologies, for smartphones, they are readily available. However, for tools such as Kinect, you're able to obtain the 3D coordinates as well as the different joints of a person. Okay. However, the cons for all of these technologies is that it only captures the visual aspect. However, it does not obtain the weight distribution and other factors that may affect gait, such as when a person walks, the distribution in the legs or in the feet essentially would not be obtained just by using visual sensors. So other technologies use wearable sensors through accelerometers. So in this case, they actually put equipment on a person to gather information, such as for accelerometers, the movement as well as the XYZ coordinates and the speed of these movement as a person is walking. There's also other studies that implemented wearable cameras as well as a special kind of flooring to determine the motion and movement of a person, as well as if a person sways from left to right. So for these wearable sensors, essentially we have, of course, the accelerometers as well as cameras, which enables us to have better information for the person to be able to see the motion, as well as to understand what happens in the environment as the person is walking. However, the problem with this one is that these sensors are essentially obtrusive, which may compromise or the regular motion or natural movement of a person. They also do not capture weight distribution, similar with the visual sensors. The next kind of sensors used by gait analysis are flooring sensors, examples of which are through pressure sensors, wherein essentially these sensors obtain voltage with respect to the pressure applied to understand the weight given by a person. So another example of this technology is through force-sensitive resistor. As we can see here on the left, this is an example of a homemade force-sensitive resistor through a conductive foam, while this one is a off-the-shelf force-sensitive resistor. The idea with this one is as force is applied, the voltage essentially would pass through, the current would essentially pass through with respect to the amount of pressure being applied on the sensor. So for these flooring sensors, you're able to obtain, of course, the weight data, as well as essentially they are thin, and some of them are cheap, especially for the homemade conductive foams. However, the industry grade or the off-the-shelf sensors are essentially expensive, and the cheaper ones are essentially brittle. But all of these sensors for flooring does not capture the XYZ. They only obtain the positioning as well as the weight distribution of a person as he or she is walking. So one of the few nearest research for this work is essentially a previous work from me and another set of my students focusing on a implementation of a low-cost smart flooring using homemade conductive foams. In this case, we tried it to determine a child's movement through running, walking, jumping, as well as possibly even fall detection. Another close work is a work that focuses on multi-sensor fusion. In this case, it is a wearable, but they are combining multiple sensors such as gyroscopes and accelerometers to have a better idea on how a person walks. So with this explanation, the idea is that we have a research gap. There is a research opportunity which incorporates a fusion of data or decision from different sensor types while being low cost and non-intrusive at the same time. So for the objectives of this study, we focus to apply machine learning to different types of sensor data obtained from a self-made low-cost smart setup, which will be used to detect gait abnormality. So the idea that we wanted to convey is we wanted to combine the sensor types that are present, which are non-obtrusive, and implement that for our study for gait analysis. So to start off our methodology, we essentially started with the tool development. We essentially used Kinect for the 3D points of XYZ as a person walks, as well as developed our own smart flooring. For the Kinect setup, we essentially have the smart flooring over here, the blue, and then we have the subject moving at a particular direction. We also have the Kinect sensor, which is able to essentially obtain the view of the subject as he or she would be walking from the start to the end of the smart flooring to obtain the different coordinates, the stride length of the person, the angles, as well as the spine movement and other, of course, movement parameters obtained from the motion. For the smart flooring, we're essentially developing our own smart flooring by creating a sort of like a sandwich of different materials, tarpaulin from top and bottom, essentially to be used to protect the sensors underneath. We also have copper tapes to essentially provide us with the conductivity while being thin and low cost, as well as velostat, which is essentially a pressure-sensitive conductive material, which becomes more conductive as pressure is applied. So with these technologies, they essentially became helpful for us to be able to create the low-cost smart flooring setup. So in this case, it shows us the two different positionings of our copper tapes to essentially create a matrix of about 600 sensors. Over here is the output of our development. As you can see, we have the tarpaulins with the copper tape lined up. And over here, we also have the velostat. So essentially, we had about 10 to 12 velostats positioned in the entire mat for our study to essentially mimic having about 600 pressure sensors because off-the-shelf pressure sensors are essentially expensive. So this is our smart environment setup in the house of one of our proponents where the test took place. So as you can see, you have the Kinect sensor over here in these two corners. They're essentially measured to be uniform for all the tests. And we also have the smart flooring over here. Next is for the data collection phase. We essentially collected from two different sensors, which we would be implementing decision level fusion afterwards. We have the Kinect sensor to obtain the kinematic data from the skeletal map of a person. We also have the smart flooring to obtain the essentially the sensor data based on the voltages caused by the weight distribution on the sensor matrix. Then, for all of these information or data that we're going to be obtaining or that we obtained, we essentially process them through time series in order to add them to our data set. So over here is our data collection result. So the output for our data collection would be only about 20 participants, 5 of which have gait abnormalities. while 15 are normal. So in this case, since we had some limitations due to the quarantine, we're not able to obtain more participants with gait abnormality. So thus, in order to essentially balance out the data, unfortunately, we had to have people act out the gait abnormalities to be able to essentially normalize the data for 15 total of abnormal and 15 normal. Okay, we had the participants to act out. We had them study gait abnormalities first, then have them act them out. So with the data collection, we had the participants walk 10 times, as well as without shoes, to be able to obtain the proper weight distribution of the feet as they are moving. We also have the data labeled by a physical therapist. In this case, she's still a student because of the difficulty in looking for a professional due to these troubling times. No, we also did, of course, follow research ethics process. So this is an example of a test data collection of one of our proponents in the laboratory. So this is the actual data collection of one of our participants as he is walking through the smart flooring. This is an example of the data that we obtained from the Raspberry Pi. The Raspberry Pi is the one that is the controller or single board computer used for the smart flooring. Actually, we started out using, for the smart flooring, we started out using our Arduino Uno. However, we needed more analog sensors to be able to, of course, have the entire 600 sensors in place for the Arduino Uno. So instead of having multiple Arduino Unos and have them synchronized, of course, for our data collection, we instead chose Arduino Mega, which has about 40 or something analog pins, which allowed us to, of course, be able to capture all the columns. However, for this one, we had some issues because the processor is kind of slower, which enabled us to only get about 2 to 4 frames per second or samples per second. So thus, we ended up with a Raspberry Pi, which has a faster processor. However, we added some additional multiplexers and decoders and the like for us to be able to obtain about 22 to 23 samples per second. So for the smart flooring, this is essentially what it looks like as we collected the data. As you can see, of course, within a single second, there are essentially multiple samples obtained from the same ID. With the smart flooring as well, we're able to obtain various other information from feature extracting the details to obtain other features such as the force, center force, step time, swing time, gait symmetry, weight distribution, stride length, and cadence. So over here shows us an example of the smart floor data as well as the different steps collected from the entire walk, which we are able to determine the foot as well as weight distribution of the individual as he or she is walking through the sensor, the essentially smart flooring. This is essentially the process data. And in order for us to, so the idea here is that a single person, when he or she would walk, the speed of the walk would be different from other people. Thus, each person has a different amount of frames. So what we did is essentially we tried to implement time series through a 10% window of the 10% intervals and obtain the min-max average of all the points and values for that for each 10% interval. So this is another sample of one of our proponents attempting to show the different points obtained by using the Kinect sensor. So in here, we are able to obtain information such as the different points, X, Y axis, as well as the length of the limbs and connection of each point, and as well as their angles, no? Which we essentially use for our data. So with the Connect, unfortunately, we're only able to obtain 15 frames per second, which in this case has a difficulty to fuse with that of the flooring, which has about 22 to 24 samples per second. So in this regard, since they are different sensors and synchronization would be difficult as we collected them, instead of implementing sensor level fusion, we decided to implement decision level fusion with the advice of other faculty members and their thesis panelists as well. So this is an example of the Connect raw data. As we can see, we're able to obtain the XY of the different points, as well as with respect to time. So essentially implemented pre-processing as well in this case with the same 10% interval of min-max average for each of the points. Then of course we implemented normalization for this one as we implemented them for machine learning. So for the machine learning portion, we had some pre-processing techniques such as for scaling methods, feature selection methods, as well as feature extraction. And these are the machine learning techniques that we use for KNN, K-means clustering, as well as using CNN. So for the results of the KNN, we essentially implemented a matrix of the use of the multiple feature extraction algorithms, as well as feature scaling algorithms to see if which one performs better, as well as those with feature importance and without feature importance for all of them, and obtain the best results. And in this case, we obtained the highest accuracy for no feature scaler implemented, as well as for no feature extraction, and PCA had the same results. For the for the previous one is for the Connect data. This one is for the smart flooring data. The highest was through LLE with using min-max scaler with both feature importance and without feature importance in the data set. And this one is for the KNN of the smart flooring, but focusing more on just the gate features to obtain the highest with no feature extraction as well as no feature scaler with feature importance. So for the KNN summaries, this is essentially the best results that we got with the highest accuracy from the Connect using no feature scaling and no or PCA implementation for feature extraction. For the smart flooring, we essentially got 87 and 81%. So we can essentially safely say that for this test, Connect essentially has a high accuracy for KNN as we tested it. For the results of the K-means, we essentially wanted to see some mathematical relationships with the data. We also implemented DBI, Davis-Baldwin Index, for this one, same with the previous presenter. And in this case, we received the lowest score for LLE with the unprocessed data set without the use of standardization or normalization. So this is essentially the representation of our result. Okay. So as we can see, the real abnormal actually went to the third cluster over here. However, this is quite inconclusive since most of the points are essentially, there's a dense area over here. So we tried, of course, for the smart flooring. So the previous one was Connect. For the smart flooring, the lowest score that we got was for LLE, for standardized implementation of here. No, we standardized the data set, normal curve. And again, lowest DBI is better. So DBI is, for us, is essentially the distribution of the cluster nodes and the cluster heads. So over here, we can see that the real abnormal, are essentially split into these two clusters. However, we can essentially see that the acted abnormal was actually nicely placed into the first cluster. So as well as in the normal is essentially distributed onto the different clusters. And then for the smart flooring, essentially we have ICA as the best. However, the DBI score over here is not too low. So this is our result, showing us that there's of course some difficulty with what happened here, as well as we can now see that the acted abnormal, the 10 acted data, essentially now produced quite different clusters over here. Showing us that there is a pattern with regards to these acted abnormal, which informs us that maybe it's best to just use the real abnormal data and just use GAN or generative adversarial networks to create more data sets from what we have rather than having them act out. Essentially, the result, again, for the overall and clean, so we have it here, standardized and LLM. For CNN, we essentially implemented data visualization. So we had the different XY points of the connect as well as the smart flooring implemented in both sides. We essentially use time aspect with respect to the alpha or opacity of each of the images over here, as well as for the flooring data, the alpha is with respect to the weight distribution, and the color red to essentially blue is the time aspect. Same with the connect, the red to blue transition gradient is essentially the time aspect to represent the motion or time difference in the data. So these are essentially the results for the smart flooring. We essentially obtained 96% as the highest one for the smart flooring over here. Yeah, without data augmentation or with data augmentation. Data augmentation in this case was the additional of the gate features. This one, I believe we're probably, I'm guessing that this is overfitted, which is why it received 100%. So, and for Kinect, essentially, we also received 96.43% for the original data set with all the layers. For you, when we try to remove the other layers from the Inception V3 model, we essentially receive 100%, which we also think might be overfitted in some way. So in this case, we obtained about 92% accuracy using CNN, using KNN for the Kinect, and then for the smart flooring, we obtained 96% accuracy. So for the decision level fusion, it's kind of obvious that the smart flooring has a higher weight from the Kinect, since the accuracy of the smart flooring is 96% with Kinect 92%. So at the end of the day, when we try to implement decision level fusion, it seems that the smart flooring always came out on top. So some conclusions. So for the KNN, we received a higher accuracy of 92%, and feature important selection has little impact. For the k-means, we were able to see some groups. However, there were some inaccuracies, especially when we were able to see the difference that it was able to detect the acted out versus the real abnormal data. For CNN, it was actually represented very well, in our opinion, on how the images were represented. And then essentially, we received a higher result for the smart flooring in this case. For the decision level fusion, again, it's kind of difficult to implement for the smart flooring because you have to build the entire flooring, while for the Kinect, it's essentially just purchase online. So with the addition of this 4% increase, it may be that Kinect would be very helpful as well already for gate analysis, even though it has slightly smaller accuracy. Bit of recommendation here for the study is to collect more data and to use GAN instead of acting it out. Use different machine learning algorithms and other fusion methods, portability of the setup, number of connects, the gap as well as of these sensors, as well as, of course, consultation with a actual licensed doctor, not just a student. So that's pretty much it. I apologize for taking up too much of the time. Thank you. Do you have any questions for me?
Thank you, Fritz. I think there's a question here. We can entertain only one.
Yes, please. So from Professor Numao, the purpose of the system essentially is hopefully for not really for medical diagnosis, but to as an expert system. So it's not really going to be an expert system, but more of sort of like additional information for a medical professional so that they have a better understanding of the data with regards to gait abnormality of a person as they, of course, are performing with their diagnosis. So we wanted this to sort of help medical professionals create decisions.
I see. Thank you.
Okay. Thank you, Fritz. Just a reminder also to the other presenters later to kindly check the Q&A tab because there's a lot of there's a late input of questions. So we'll be proceeding with the next presenter, uh, entitled "Exploring the Persuasiveness of an Emotional Intelligence Training Application Using UFAID" by Ms. Alisa Yubay and others.
Hi, good afternoon, everybody. I hope you could see the slide. So, in behalf of my fellow researcher, I am Maria Rowena Sisolama, and I will be presenting our paper, Exploring the Persuasiveness of an Emotional Intelligence Training Application Using UFAID. Our research objective is basically to explore the persuasiveness of Maintain, an emotional intelligence training mobile application that focuses on encouraging users to regularly exercise their emotional intelligence and monitor their emotional and mental state using the unified framework for analyzing and designing and evaluating persuasive systems. Emotional intelligence is defined as the ability to perceive, manage, and assess your emotion and others' emotion. So it is commonly known as an emotional quotient of an individual, where it describes his or her level of emotional intelligence, often represented by a score. Many studies have examined the predictive nature of emotional intelligence and its domain to mental health. Students with high emotional intelligence have been revealed to be less likely to externalize problems and be emotionally adjusted than students with lower emotional intelligence, who are found to be prone to engage in harmful behaviors. So the emotional intelligence of an individual can increase by undergoing several emotional intelligence training or interventions. Emotional intelligence training can concentrate on self-awareness, motivation, empathy, etc. So to help the group in developing a mobile application, we use the unified framework for analyzing, designing, and evaluating persuasive system, or we call the UFAID. So it is a framework that was proposed by Wave and Frempong back in 2015. Um, it provides a systematic approach that facilitates persuasive design and addresses the issues of changing needs of users by considering external and internal activities that can possibly promote or impede persuasion before and after implementation. UFAID has actually 28 system features that can be incorporated in the design of persuasive technology. So it's the table found on the slides. UFAID also asserts the necessity to evaluate actual changes in attitude and behavior that occur during the use of the persuasive system. So in our study, we use the theory of planned behavior by Asgen. Having a before and after analysis allows the identification of other related changes in the users, which is not explicit, yet it impacts the target behavior. So for example, after using an application to promote eating vegetable, a user may change his attitude towards vegetable and yet may not be eating them. Such information can inform the developers on what to do next, since the intent of the design is not achieved. So in this study, we develop Maintain, the mobile application. So it's a persuasive application that focuses on encouraging users to regularly exercise their emotional intelligence. By increasing their emotional intelligence, users are better equipped in adapting to stressful environments and maintaining their positive well-being. So there are three emotional intelligence training that is supported by Maintain. One is that's reflective journaling, active listening, goal setting, and tracking. So for reflective journaling, this emotional intelligence training helps develop self-awareness and self-regulation, which entails looking inwards to oneself. So the module facilitates reflection writing. A key feature of the modules are the reflection prompts, which helps users start the reflection writing by giving out starting phrases. Another emotional intelligence training is we have active listening, which helps develop self-awareness and social skill. So it demands a person to place his undivided attention and awareness to the speaker's disposal, to listen to the speaker with interest, and to appreciate without interrupting. So in our module, there's actually a listener checker that guides the user in paraphrasing conversation and making users more conscious of traits or characteristic of active listening that they portrayed through a checklist. So a key feature of the module is we have conversation prompts, which helps the user to start conversation. Another emotional intelligence training is we have the goal setting and tracking. So this helps develop self-motivation. Our module allows user to set goals with deadlines, the level of urgency, subtasks, and expected output. It has also reminders and alerts and provide praises if the user has achieved a particular goal. And then we also have the mental health monitoring module, which helps the participants monitor their mental well-being. We use the emotional intelligence scale by Shoot, the 1998. This is fairly standard, and we use it because it's free for non-commercial use. Also to Maintain also has the following UFAID system features. So we have the system as the self-monitoring rather, where Maintain offers assessment that keeps track of the emotional intelligence and mental well-being scores of the participants. Another feature of UFAID system is we have reduction, where activities in Maintains are broken down into steps. Entry input consists of multiple screens to reduce data input at a given time. We also incorporated suggestions where we have the reflection prompts and conversation prompts readily available to the participants. We have the reminder where user sets their daily or weekly notification for each of the activities it facilitates. And we have praise where we provide positive feedback when users do activities in the application. Our research methodology, basically it's an experiment where participants are asked to download the application and use it over a 7-week period. And our participants, we started out with 39 recruited. However, only 31 answered the preliminary theory of planned behavior questionnaire, and only 25 finished the experiment. Answering both the theory of planned behavior post questionnaire and the persuasiveness of UFAID system questionnaire. Each participant had a unique participant ID that could be found on the application settings, and the application installer was accessed by the participants through an online link. So once that they have access to their participant ID, the theory of planned behavior preliminary questions on attitudes and behavior was answered online. After that, the participants started using the application for the duration of the 7 week. After the 7 week, the participants answered the 2 questionnaires, the theory of planned behavior questionnaire and the persuasiveness of UFAID system features. So that's the research instruments that were used in this study. For the theory of planned behavior, the following constructs were analyzed: the past behavior, intention, perceived behavioral control, subjective norms, and attitude. We also did a follow-up interview just to try to investigate further certain results of the survey. So what's the analysis and the result? So UFAID insists of having a before and after analysis in attitude and behavior, the result of which are used to guide or inform the improvements of maintains in terms of persuasive design. So I think a most significant finding that we have is on the past behavior. So past behavior is used to help understand or uncover if doing the emotional intelligence training with Wuntaing has something to do with their past behavior. So to help us analyze, we use a chi-square because of the qualitative data. And the result shows that for reflective journaling, goal setting and tracking, and mental health monitoring, The results showed that doing the emotional intelligence with Maintain will most likely be done by those who do those emotional intelligence training. Of particular interest for active listening, if you notice from the table, majority of the participants after this experiment still have no experience using active listening. Excuse me. Further investigations show through interviews that participants have different expectation of what active listening is. Excuse me. As there are many other different types of active listening. Also, they have different initial experience than what the module offers. Like some of them expects a score on how well they did with active listening rather than just simply checking if they have done it properly. Excuse me. For intention, so this is used to understand the participant's intention in doing the emotional intelligence training. So for we did for this section, we did a paired t-test. And then for the reflective journaling and goal setting and tracking, there is no change in the intention. However, interestingly, for active listening, intention decreases from 2.52 to 1.72. So the paired t-test showed that this difference is significant. So this may be attributed to the different expectation on what active listening is, as mentioned earlier, and that the lockdown due to COVID-19, as participants have limited option to whom they can talk to because it requires a more social circumstance. For perceived behavioral control, subjective norm, and attitude, there is no change on those aspects. So as can be seen by as a result of the paired t-test. So what's the implication of this to the persuasive design on Maintain? So past behavior may encourage user to perform the activities in the future. So this guides the persuasive design to use past behavior as part of the messaging to encourage initial use or maintain emotional intelligence training with Maintain. So basically, if they have done the activity before, it means that they could also do the activity now and then in the future. Also, active listening module, we found out needs to be reanalyzed and redesigned in terms of the expectation of the module and how it can better support the exercise on active listening. So the analysis on the persuasiveness of U-Fade system feature. So the result of this one, so we found out that the self-monitoring and reduction have higher scores. So this indicates that in terms of persuasive design, we need to continue having simple interactions to make Maintain easy to use. For the suggestions, further investigation show that reflection prompts for reflective journaling, participants look to reflection prompts, but the prompt failed to help them start writing their reflection. It was suggested that the content of the prompt should be tailored to the needs of the users. For conversation prompts for active listening, participants did not use the prompts because of the issues they were having with the module, as stated earlier on. For the reminder and praise, they also occurred lower scores. And further investigation showed that it was suggested that the frequency, timing, and message framing need to be considered as opposed to have them on fixed interval or at fixed responses. So in summary, the study provided the following to guide the persuasive design of Maintain. First, the use of past behavior needs to be part of the messaging to encourage initial use or maintain the emotional intelligence training with Maintain. That the module of active listening needs to be reanalyzed and redesigned on how it could be better support the active listening exercise. To continue having simple interaction, to tailor the content of prompts to the need of the user, and to consider frequency, timing, and message framing in designing reminders and phrases. For future works, in terms of the development of Maintain, of course, we need to implement the result of the study. But others, based on further follow-ups interview, they want to include facilities for social support, consider having dynamic and personalized content, have options to turn on and off notification, add calm music, and randomize the question for the mental well-being scale. Of course, there's a lot of improvement that needs to be done on maintenance experiment. First, we need to have it a long duration. So instead of 7 weeks, it should have be more weeks. Also, we need more participants as yung 25 participants, medyo problematic siya dito sa study na to. But we need also to take into consideration on how they can complete the experiment without affecting their answers to the questions, questions of the questionnaires. We also need to improve the questionnaire, and the theory of planned behavior post-questionnaire needs to be given at intervals within the duration of the experiment rather than only once in the end. And then we need to consider the environment and timing of using maintain because these two have impact on how they use maintain. And finally, we need to consider a third-party perspective because behavior is observed. So attitudes may change, but the actual behavior may not. So we need to observe that there is actually a change in behavior. So these are all the reference, and thank you very much.
Thank you, Ma'am Weng, for the comprehensive presentation. Since we are a bit early, I will be entertaining several questions. Kindly type your questions onto the Q&A, or for the panelists, you might also want to turn on your mics. Thank you.
Hello, good afternoon. This is Yami, and I have a question. I like the presentation, so I think it's very useful. I just like to find out the profile of the respondents and how they were chosen.
We actually invited several students from UP and also outside of UP because of what happened in the pandemic. So to ensure that we had enough. We thought we had enough. So the profile of the ages would range from 18 to 25 years old.
So they're mostly students and
yes,
faculty.
they're mostly students.
Okay. I wonder if the language can be contextualized because I was thinking from the perspective of disaster risk and reduction management. So, for example, now in Catanduanes, I would imagine mental health support is needed. So, if the language were in Bicolano, maybe that would encourage more people to use it because if it's in English, I assume it's in English. If it's in English, then you limit the people who could actually use it. What's your thought on this?
Actually, yes, that's one of, as was suggested by the participants, that we need to make it more customized or personalized. And one of the, I think we're thinking about would be the language. Because I think our prompts, the reflection prompts and the conversation prompts are all in English. And then sometimes I don't think they understood how the prompts are actually used. So that's also one of the things that we are actually thinking about of making it more customizable or more personalized.
Okay, sorry, this is my last question.
Yes, it's okay.
I wonder if you're also working with some counselors, because if it's meant to be some sort of therapeutic, then maybe counselors who can guide in the design of the prompts and the sequence, and if it's meant to be customized later on.
Actually, we ask help from counselors and psychologists. In fact, in choice of the emotional intelligence scale came from them. So they gave us parang a set of scales that we can actually choose from. And we just basically chose this one for its simplicity, and first, it's actually free for use. But yes, we also need their help. Actually, if you notice, one of the major would be how we would present the messaging or how we would be able to customize or personalize our messaging. Yung basically determine how is the approach, how is the how we will approach the messaging, even the timing and frequency of the reminders and the feedback.
Okay, thank you.
Thank you. Thank you for the questions.
Are there any questions? If none, I will be proceeding to the next presenter. Thank you again, Ma'am Weng, for the presentation.
Thank you, Justin.
The next presenter will be from Ms. Charlotte Kai and others, entitled Development of an Automatic Speech Recognizer for Filipino-Speaking Children. Hello.
Hello. Okay. Hi. Wait. Where's that?
Yes, you may start.
Okay. Wait. Where's that? Okay. So hi. I am Eduardo Te, and I will be presenting with my groupmate Matthew. Today we'll be discussing our system, which is the development of an automatic speech recognizer for Filipino-speaking children. So our outline for this would be introduction, and then we'll be discussing the automatic speech recognizer, the speech corpus that we're using, the feature extraction, the acoustic modeling, the phoneme recognition, and then our results and conclusion and recommendation. So the automatic speech recognition, or ASR, has been available for quite some time now and is widely used around the world. However, ASR systems that are made specifically for children are scarce compared to ASR systems for adult speakers. Currently, however, there are no ASR systems that are made specifically for Filipino-speaking children. So majority of the systems right now that we see, like for example, the Google ASR, they're mainly focused on adult speech. So the children ASRs, the reason why we wanted to develop children ASRs because they can be quite difficult. The way the child articulates vowels and consonant sounds are different compared to the way adult speakers do, and because they have limited speech proficiency in the language that they speak, and they are more prone to grammatical and pronunciation errors. So the speech corpus that we are using is the FCSC, or the Filipino Children's Speech Corpus. This corpus contains about 8 hours worth of data. The speakers are students ranging from grade 1 to 5. This speech corpus contains recordings of 2,169 words coming from text passages of 9 Filipino short stories. Previously, before we got our hands on the data, there were only about 1.5 hours worth of transcribed data. So we'll be calling that as the originally transcribed. And then the remaining 6.5 hours, we transcribed it ourselves, which is the rest. So to give like an overview of what it is, there are 7 speakers that were originally transcribed, and then us transcribing, which is the newly transcribed, are 36 speakers. So for the speech transcription, the speech transcription that we chose to transcribe it on is on a phoneme level, and we are using a phoneme chart, which would help us, and which is our basis for transcribing. The phoneme chart contains about 33 phoneme sounds, and they are all present in the speech corpus. So these are the phonemes that we have. The p, b, t, the typical phoneme sounds that you have. However, in the Filipino language, we have one distinct, in this chart, we have one distinct phoneme, which is the Q, or the glottal stop. So for example, in Filipino, we have in English the word foot. In Filipino, it's called paa. And when you say paa, there's pa and a. After the initial pa, which is there's an A sound and then like a minor stop, it kind of like cuts early. That's called a glottal stop for future reference. So next. So our manual transcription process, we have speech recordings, and then we'd input it into a Pratt application, which would output time-aligned phoneme transcriptions, and then we would manually adjust the rest of it if the time-aligned transcriptions that came out were a bit too off. So Matthew.
Hello, good afternoon. Can you hear my mic? Can you hear it?
Hello? Yes, we can hear you.
Okay. So good afternoon. So regarding the feature extraction. So the feature extraction is responsible for extracting the speech parameters of the speech recordings or the information from the audio. So the chosen method we used for feature extraction was the Mel frequency capstral coefficients, or MFCC. So the job of the MFCC, it converts audio and time domain into frequency domain to help understand all the information present in speech signals. So to elaborate further, the MFCC is commonly used in speech recognition. This is also due to it being known for its accuracy in estimating speech parameters and efficient computational model of speech. So the MFCC, as mentioned, extracts features of an audio signal that allows the identification of linguistic content while disregarding unnecessary factors such as unwanted noises, the voice quality, or the gender of a person, or emotion. So the software that we use for feature extraction is the Hidden Markov Toolkit, or HTK. So to use the MFCC, it requires the raw speech recordings from the speech corpus as the input. So going to the acoustic modeling. So the model that we use for this study is the Hidden Markov model. So first, the Hidden Markov model, it's a model that depicts every observable event as a state. So speech signals are normally continuous, so it's going to be difficult to determine when and how an abstract speech code transitions to another. So an explicit definitive observation of a state, we cannot assume that. So we can only approximate from the sequence of observations produced by the system. So the number of states that we used for the HMM is a 4-state HMM because it represents the optimum results, as we will discuss later. It is left to right because it cannot go back to a previous state. So it can either go back to the current state or it goes to the next state. So this is an example, a state diagram of the 4-state left to right HMM. So as you can see, there are no arrows that points to a previous state because it can only either go back to the current state or it goes to the next state. So the state 1 and 6, they are not considered as states because they're non-emitting. So that means they don't have any output probabilities or observations. And the A denoted by 2 digits, so 1, 2, A, 2, 2, that represents the transition probabilities. Now going to the forced aligner. So the forced alignment is the process of finding for each fragment of the data transcript the time interval of the speech file containing the spoken text of the fragment. So the method that we used for this is called the Viterbi forced alignment. So to discuss briefly about the Viterbi algorithm, it finds the most likely alignment of sequence of the generated HMMs of the speech data. So the Viterbi algorithm, it computes for the most probable sequence of states for the observations. So how it does this is it computes for the transition probabilities from one state to another. So the sequence of states with the highest computed probabilities will be the one that will be chosen. So how will we know if this is the transition from one phoneme to another, if it's the end of the phoneme? So how it does that is the computations are drastically changed. That's how it will find out if it's the next phoneme already. So now we will go to the results and analysis. So first we did a test between a 3-state HMM, a 4-state HMM, and the 5-state HMM. So in all 43 speakers, there are 9 stories, Filipino stories, and there are a total of 144,458 phoneme occurrences. And as you can see in the accuracy results, 5-state achieved the highest recognition accuracy. So why did we choose 4-state? Because as we found out, the 4-state achieved, take note that this is the phone level results. In the word level results, we achieved a much higher word level recognition rate compared to 5-state. And we're not really sure on why that is. But we still chose 4-state for that, since it was higher accuracy. And as you can see from the 3-state accuracy, it's much larger compared to the difference or the improvement from 4-state to 5-state. So the second test is the number of re-estimation. So what are the re-estimations? It's the re-estimation of the HMM models. So there's an algorithm for this. It's called the Baum-Welch algorithm. So a brief discussion of the Baum-Welch algorithm is it's a maximum likelihood algorithm that provides a maximum likelihood estimate. So what this does is maximizes a sequence of observations. So in a way, it optimizes the HMMs. So this is the graph. Sorry if it's not that clear. So as you can see, there are 3 systems. So first, let's discuss this. Let's discuss the systems. So the 3 systems is basically the difference is the amount of training data. So there are 43 speakers in our speech corpus. So the initial systems contains the least amount. So it's only 7 speakers. And the partial system contains 23 speakers. And the full system contains all 43 speakers. So as you can see, there is in the re-estimation, we re-estimated 8 times, so up to HMM 8. So as you can see, the performance improvements plateaued somewhere at around HMM5. So we decided to stop at HMM8 because there's barely no improvement at all. Well, you can still test until the number of times you want. We also tested until HMM20, but there was really barely any improvement at all. So it really plateaus at a point. So for the phoneme recognizer, we also tested this, and uh, we took down the average phoneme recognition results. So for the initial system, the average accuracy is 47.84. Intermediate system 48%, and the final system achieved the highest. So the average accuracy of the data that are not included in the training data. So this is the isolated data. It's only as used as the test data. So the final system achieved the highest accuracy. And the problems that we encountered was having a dissimilar transcription within the speech data. So this had a really big effect on the final system. So this was obvious in, as discussed earlier, there were two parts of the speech corpus, the originally transcribed and the newly transcribed. So the originally transcribed had different transcriptions. So example, in the Maya, or in English, it's bird. So in the few transcriptions, it's just MAYA, but in other transcriptions, it's MAYA, as well as how, or thirsty in English. It's U, ha, W, or U, ha, and ow. And there's also in our process of transcribing, we didn't really include much glottal stops in the transcriptions. Like Q is the glottal stop symbol. So in other cases, it's IEENOM, and other times there's the glottal stop EQINOM. So that had, because of the differences, it had a big effect. It really pulled down the accuracy of the system. Then we also conducted tests on the forced aligner. So for the forced aligner, we conducted a time difference test. So what this means is, example, in the manually transcribed versus the forced aligned alignments, if the difference from the manual to the forced aligned is more than 10 millisecond, then we counted it as an error. As well, and that applies to the 20 msec, 30 millisecond, 40 millisecond. So the accuracy for the 10 millisecond was really low. So because it had to be really close for it to be counted as a non-error. But it went above 50% when it reached 20 milliseconds, and it was almost, well, it reached 73% in the 40 milliseconds, only having an error of 26.54. So with the problems we encountered in the forced aligner was having unnecessary noises, such as voices of other people, clicking of a button, or and other noises like errors in the child's like speaking. So this really sabotaged the alignment process. So it caused misalignments. Now for the word recognizer, we also conducted multiple tests. So we took the average word recognition rate, and for all three systems, the final system achieved the highest word recognition with the training data of 43 speakers. So the most amount of training data, it achieved 57.9% accuracy. So the word error rate, it simply subtract the accuracy from 100. That's how you get the word error rate. So the initial system achieved the lowest one, since it also had the lowest amount of training data. So the problems that we encountered in the word recognition or the word decoder was the word pronunciation dictionary did not have enough word pronunciation sequences. So the word pronunciation dictionary, so it's simply a file or a list of all the words that appeared in the speech corpus. So there's around 650 as previously mentioned. So there's a lot of different ways of how a word is being transcribed, such as the problems that we encountered in the phoneme recognition. So there's a version of a word that does not have a glottal stop, and another version of a word that has a glottal stop. So we have to include all of them. Then going to the conclusion and recommendation, Ed will present. Thank you.
Okay. Hello. So in our conclusion, the word ASR achieved a higher overall recognition accuracy of 57.9%, as compared to the phoneme level ASR, which only reached an overall recognition rate of 50.26%. Having different phoneme transcriptions can affect the recognition accuracy. So, as mentioned by Matthew earlier, some words have like phonemes have glottal stops. Some of them don't. Some of them pronounce two consecutive letters as just one, etc., etc. And then, as through our findings also, that adding more data may not help significantly in improving the system's accuracy. So you may want to look into other machine learning algorithms. And the use of the bigram model and dictionary help increase the recognition accuracy for the word level. So the overall results of the force aligner were not far from the supposed time. Unnecessary noises can affect the force aligner also, as mentioned by Matthew earlier, with the button presses and everything. Even though the final system, however, has an overall recognition rate that may be considered inferior to those from other studies, such as Gray et al. And Bautista and Kim, there are not enough bases for direct comparison, because this is kind of like the first of its kind. And the results from this study can serve as a baseline for any similar studies in the future. So our recommendation is to look into different machine learning methods to see whether the accuracy would increase. You may want to explore other modeling approaches, such as deep neural networks or a hidden Markov hybrid with a deep neural network, or look into artificial speech vectors to fill in the need for more speech data when using neural networks. Of course, for rechecking and retranscribing the speech data, so we can so that the data is a lot more uniform. Also to change the phonemes and add more phonemes to the phoneme charts, because there are we encountered some where the phonemes weren't well represented, or they weren't they weren't well represented. And to add more possible pronunciations to the word dictionary. So that's it. Thank you.
Thank you.
Okay, thank you, Ed and Matthew. Are there any questions from the panel or from the audience? To those who just came in, you might want to type your questions on the Q&A tab, and the presenters will also check to answer your questions even after their presentation. Also, the panelists can also ask questions from the presenters. Let's just wait for the questions. You might want to type it later. We are a bit early, but we'll be starting the next presenter by Judith Escaraga and others, entitled Building a Corpus of Emotional Facial Expressions Towards the Development of an Affective Filipino Embodied Agent.
Yeah, is it my turn now, John?
Yes, please, ma'am.
Thank you. So let me just share my screen. Good afternoon.
Go ahead, ma'am.
Okay, can you now see? Okay, yeah. Yeah, good afternoon, everyone. I'm Judith Escaraga. I'm presenting on behalf of my students, so Joshua Del Barrio, Shan Lee Kim, Miguel Rivera. So the title of our research is Building a Corpus of Emotional Facial Expressions Towards the Development of an Effective Filipino Embodied Agent. Okay, so so facial expressions are one of the many ways we humans communicate our inner emotions with one another. And as you can see, so these are the 6 basic emotions, and one is actually from a movie, Inside Out. So these are the different characters, and they are labeled according to the emotions they express. Facial expressions actually are very important, because this is a two-way form of communication, and a person's facial expression can be used to convey messages. And according to the creators of this movie, and also the TV series Lie to Me, the one on the right, Paul Ekman, there are 6 basic emotions, which are sadness, contempt, surprise, anger, disgust, and fear. Okay. Actually, there are many researchers questioned whether or not expressions differ between cultures and other influences. Previous studies have shown that facial expressions are shown in a similar way across cultures. A study conducted by Paul Ekman and Wallace Friesen in 1971 concluded that facial expressions are universal, meaning they are shown in the same manner given the same context. However, this research was challenged by another group of researchers, Japanese researchers, Sato, Inewaska, Minemoto, and Yoshikawa, that claims that facial expressions are not in fact universal, and they vary from culture to culture. So this is actually our motivation. Our motivation is to create an embodied agent that is able to express emotions based on Filipino facial expressions. Now, to do this, um, in order to build, we need to build an effective Filipino embodied agent. Now, for us to do this, we have to create a corpus or a data of emotional facial expressions of Filipinos. And then, so once we have the corpus, we need to develop a system that automatically captures facial points from images and processes them to aid in building a corpus of Filipino facial expressions. And to create also what we call as an embodied agent that can express Filipino basic emotions such as happiness, sadness, fear, disgust, surprise, and anger through facial expression using the corpus that we have. Now, for the experimental setup, first, of course, since this involve human participants, so we need to give them consent forms, and approve the forms, because of course they will be participating here, and then their facial expressions will be captured by a camera. So we gave consent forms to the participants as well as those who evaluated the video clips. Now, actually, in this research, we asked the participants to watch several video clips with the goal of eliciting different emotions. So the emotion stimulation is actually based on the video clips. And these video clips were evaluated by 5 adults, no, 1 female and 4 male, just to get them, get anonymous decision as to whether we can show these video clips to our participants, and whether it can induce different emotions. So once the participants sit for for the experiment, so for every video that they watched, they needed to report the emotion that they felt and the intensity, whether low, high, or moderate. And of course, we need to have a camera. We need to set up a camera. We use the laptop camera, and that is actually 1 to 3 meters away, no, from the participant. So we took the facial video of participants while they're watching video clips. And then, of course, we had to adjust the angle or orientation of the laptop camera based on the participant's height. So we allotted about 20 minutes per participant. Okay, so there were a total of 14 participants. 4 of them were female, 10 were male. However, 1 was omitted due to them expressing no emotion. And also, we were also limited with the number of participants because of this, the quarantine. So we were not able to have a face-to-face data collection with participants. So that's why we are left with 14. And also for the 6 basic emotions for the embodied agent. So we use the happy, sad, anger, disgust, fear, and surprise basic emotions. Now, we did not use other emotions for our embodied agent. So, and we just focus on the 6 basic emotions. And then, so we had to manually extracted the frames, no, from the videos of the 14 participants. And there were about 2,000 plus frames that were extracted. And from the extracted videos, we asked 2 annotators, 1 male and 1 female. These annotators have high emotional quotient for them to determine which part of the video they saw this particular emotion, what is the intensity, and they also provided us the timestamp where they saw this peak of emotional expression. And so we took 3 frames, okay, per emotion. So from each video clip, so we got about the start. This is the first few seconds, and then the peak, okay, somewhere in the middle, and then at the end. So also the peak we had to determine, which was the peak observation of the emotion. Now, so we had to create a system that is able to capture facial expression, facial points from images. So we have developed a software that extracts the 68 facial points of these facial expressions using Python, DLive, and OpenCV, open source libraries, since they have the needed functions for facial point extraction. Now, the software first normalizes the frames fed to it before it extracts the 68 relevant facial points. The facial points Cartesians coordinates are then taken and will be used to build the corpus. Now, after the corpus was created, the data underwent through machine learning algorithm to determine the position of the facial points for each emotion and intensity. The facial expressions that the embodied agent is able to convey are based on the thresholds produced by our machine learning algorithm, which is the decision tree model. Okay, so next is, of course, we have to clean the data. We have to prepare the data. So to prepare the data, we perform normalization first on them. So the normalization was based on detecting the position of the eyes, and the rotation is done by rotating the face until the eyes fall parallel to the x-axis. To calculate how much rotation is to make it a straight line, an arctan function is used. The center of rotation is then computed by finding the midpoint between the eyes, and then the scaling is done at the same time by using the distance between the eyes as a reference and using the rotation matrix function of OpenCV. Now, when the rotation matrix is applied onto the image, it is rotated and scaled based on the values inside the rotation matrix. So what you see on the right is the images before and after the rotation matrix has been applied. Now, after normalizing the frames, the system we built can detect all 68 facial points of the face within the frame. The one on the right, these are the 68 facial points. Now, this was done by using a shape detector that has already been trained to detect faces. Now, after it detects a face, it creates a bounding box around it, which makes it easier for the system to detect each facial point within it. Each facial point's Cartesian coordinates will be transferred into a comma-separated file in preparation for training in a machine learning model. Okay, now actually we use a RapidMiner data mining tool to help us build a decision tree. Now we use the decision tree to determine the thresholds for each intensity per emotion. Now the normalized and preprocessed data was then used in building the embodied agent. So again, we use a decision tree algorithm why decision tree? Because the model produces a tree that can provide insightful information like features that are found to be important in the classification. They are easy to understand and interpret because of the visualization of the tree. Now, as such, facial points and their threshold values that are found to be significant in expressing basic emotions were identified by the decision tree. And they are used, that's what we use in creating the different emotions of the embodied agent. Okay, now we created male and female embodied agent. So to do this, we had to use a smart body software. This is a 3D modeling software. With this, we can create a 3D character model or make use of one that is already available in the software to create an embodied agent. So with this software, Smart Body, we program it to possess the physical characteristics of a Filipino, such as the brown skin color, dark hair, and eyebrows. Now, also with this software, Smart Body, it allowed us to manipulate the embodied agent's facial action units, body movement, and speech using the behavior or following the behavior markup language. Now, actually, the facial action units here, this is what the Smart Body is, what Smart Body understands. No, this is the facial action units of Paul Ekman. This describes the fine-grained changes in facial expressions. So this is actually you have a combination of facial action units. You have a emotional expression. So an emotion is actually a combination of the different facial action units. Okay, so here we have 6 expressions, 6 basic emotional expression with 3 intensities. No, so low, moderate, and high. And we had to adjust the face of the embodied agent, no, according to the facial action units. Okay. Okay, actually, so sorry, I need to go back to the previous slide. Now here, the challenge here is that since the Smart Body uses facial action units in its markup language, while our system only or can capture facial landmarks or facial points, we needed to transform our facial landmarks to their corresponding facial action units. Now, the one you see on the right, this is the flow chart that describes how we made use of the decision tree to help us create facial expression on the embodied agents. Now, to do this, we need to get the threshold values of facial points generated by the decision tree model. Next, we need to map these facial point values to their corresponding facial action units. Then we program our embodied agent using the generated facial action units. And after this, we capture the embodied agent's face and run through the same software used to normalize and detect facial points the way we did with the face detection and normalization of the facial points of human participants. Now we had to do this for all the three intensities. Okay, now as you can see, so these were the generated facial expression of Filipino basic emotional expressions for happiness. As you can see, there are three intensities. So you have the intensity 1, this is the low, intensity 2 is the moderate, intensity 3 is high. Now take note that these emotional expressions are based on the corpus that we gathered from our human participants. So this is what we got for the happiness, and then this is for the sadness, and then this is for the anger. Okay, these are the Filipino facial expression. Now you may want to compare it with Paul Ekman's basic emotions. So well, it's not too different, no, compared to the universal expressions of facial expressions or basic emotions of Ekman. Okay, and then we have sorry, I lost something. Okay, sorry. Okay. Okay, sorry for that. So here we have again the three emotions, no, happiness, sadness, anger, and then of course the embodied agent. They have we need to ask the evaluation of a psychologist, no, whether they are really expressing the Filipino facial expression. So and then there's this stronger eye and mouth expressions needed according to the psychologist. And also there are only a few facial expressions that were able to convey their respective emotion and intensity clearly. Now another, okay, so these are the evaluation of the psychologist. So for happiness, so the female looks natural, but for the male, the wider smile, squinting eyes do not convey happiness. Okay, and then for the sadness, there's this, according to, for the female sadness, only intensity 3 looks natural. But for male, prolonged time for sad face to establish emotion. Then for the anger, so again, for female, only intensity 3 looks natural. And then for the surprise, so this is the surprise expression of the embodied agent. So again, female, we have a good feedback for the female embodied agent. Intensity 3 looks closest to being surprised. However, for the male, the eyes and mouth are lacking emotion. For disgust, so here for the male, it needs to improve the expressions. Then it looks not for the female looks natural. Intensity 2 and 3 convey disgust. And then for the fear, for the male, it needs to improve lip expression. The eyes are okay. But for the female, presenting more worry than fear. Lips expression can be further improved. Now, to conclude, we were able to accomplish this. So we were able to build a corpus or data of Filipino emotional facial expressions. And we develop a system that can automatically capture facial expressions. And then we were able to develop a system that can automatically capture facial landmarks. And we were also able to develop an embodied agent that can express 6 basic emotions such as happiness, sadness, anger, surprise, fear, and disgust in 3 different intensities. Um, and then we use a machine learning model, the decision tree, to for us to determine which facial points are found to be significant in expressing a particular emotion. Now, for future work, um, so we were, of course, we were limited by just 14 participants. We wanted to have more in the future, 30 more participants, and give them also an emotional quotient test, and then maybe more videos for video segments for anger, sadness, and fear. And then we wish to have a higher resolution and frame rate for camera. And also for the emotions, we just limited it to 6 basic emotions. We wanted to also explore other emotions other than these 6 basic emotions. And then for the frame extractor, we had to do this manually. So hopefully in the future, there's a system that can automatically identify the peak of the emotion and be able to capture the frame for that. And then also future works include to come up with our own smart body type of 3D modeling, because this work is basically we just use the existing agents of the smart body and try to modify it so that it will look like a Filipino. And also, a future work may also include uh, have an embodied agent that can also talk, or and also to improve the facial features to look more like a Filipino. That's all. Thank you very much for listening.
Thank you, Ma'am Judith. For the there's a question already here from Professor Numao, so I'll just read it. So the decision tree learner removes redundant attributes, that is, feature or parameters. Embodied agents have many redundant parameters to represent an emotion. Therefore, the decision tree cannot check all the parameters. To overcome this limitation, we have to extract all the features that have gained more than the threshold, even if the decision tree does not include it. What do you think?
We were not able to address that, but yes, I think it's also good to use all the features, no, and not only rely on the decision tree threshold. It's good to explore that in the future, but because of the time limit, we were not able to do that. Thank you for the suggestion, Professor Numao.
Thank you.
Okay. Are there any other questions? Okay. So there's a question here from Kim Peñalosa. Since there are some I think this is, yeah. Since there are some Filipinos with face deformities such as strabismus, facial lump, or partial face paralysis, will this affect the recognition?
It depends actually on the face detector program. If if the program can handle noise or some irregularities in the face, so it can also be used for those kinds of cases. So we need to maybe modify the program such that it can also handle noise. Actually, some of the noises could be not only those, but the eyeglasses might be another factor that can also affect the detection. So yeah, it depends on the face detector program.
Okay. Thank you again, Ma'am Judith. Later, you can still send questions to the presenters, but there's a request actually that there will be a quick bathroom or coffee fix break for 5 minutes, so that we still have two presenters, but we'll have a quick break. We'll be proceeding again with the usual schedule break. Okay, thank you.
Thank you.
We'll be starting at 3:45. But there's a question here, Ma'am Judith. Maybe you can check also the Q&A tab. Thank you. Hello, everyone. We'll be starting in a minute. So for the next presenter, kindly stand by. Thank you. Okay, we'll be proceeding with our session for this afternoon. So the next presenter would be Michiko Go and others on the implementation of various machine learning techniques to identify or characterize basketball shot patterns using open pose. Kindly proceed.
Hello. So it's me again. On behalf of the students, I would be presenting the work. This is actually an ongoing work by the students, and in the hopes that they finish early next year. No. So again, this work is the implementation of various machine learning techniques to identify or characterize basketball shot patterns using open pose. So for the outline for this presentation is we'll start with the introduction, then go to the methodology, data collection, a bit of machine learning for the pre-work, as well as just some pre-results and analysis, since again, this is an ongoing work, and then some results and recommendation. So for this work, we essentially look for works which are related to this one. But the idea starts with understanding sports science in the essence that when performing basketball or other sports, there's of course some kinematic movement and motions, which can be used to determine if there are patterns with regards to how a person shoots, how a person scores in various sports, to be able to determine some similarities with regards to, for example, scoring or shooting or movement with respect to like winning moves, as well as moves that essentially are not the best, like performed by professionals and the like. So we wanted to understand these things. And to start off, we started looking for related works that looked at sports sciences, particularly for basketball. So to start with, one of the works focuses on using wearables such as a 3D acceleration and gyroscope sensor to obtain the XYZ coordinates and joint positions of a person as he or she is moving throughout the court, as well as shooting. Another work would be focusing on also using wrist-worn sensors. And in their work, they essentially use time series to capture the motion orientation and acceleration. And another one uses sensors placed in the arm as an arm sleeve, which essentially it comprises of an accelerometer as well as a gyroscope to be able to obtain the 6 degrees of motion or freedom. So those are for the wearable sensors. We also looked at the possibility of using camera or non-obtrusive sensors. In this case, one of the research works uses sports VU. So this is essentially a camera setup wherein the ceiling of a gymnasium or a stadium is lined up with some railings with camera that essentially is used to be able to detect players and motion while playing a game. So in their case, in the case of using this technology, it essentially takes multiple images and shot trajectories from the multiple cameras deployed in the area to obtain some visual information about the shot process in basketball, as well as another work that uses the Kinect sensor to determine some kinematic data with regards to how a player shoots and scores. But for this particular work, it's mostly for the rehabilitation process. So just to summarize some of the findings for this work that we're looking at is that for the wearable sensors, of course, they're using 3D accelerometers and gyroscopes to be able to determine motion, as well as wearable devices. However, the cons for this one is, of course, the devices would be obtrusive to the person, as well as may cause unnatural movement. So with the works that we've seen, the idea that they, of course, conveyed as well is that since the player or the person is wearing additional equipment or devices which they do not typically wear, the motion patterns and as well as the movement of a person sometimes are qualitatively not as natural as if it were non-obtrusive. So, however, for the vision sensors using cameras as well as Kinect sensors, there's of course some limitations as well, even though we can get a lot of information from them because Kinect V1 and V2 have already been phased out for many years already, as well as if you essentially use smartphones or cameras, so by default, they lack feature extraction natively. No? They are able to capture pictures and videos, but you still have to perform some pre-processing techniques for this one to essentially extract the needed data points. So one of the nearest research that we found for this work would be this work focusing on the prediction of basketball free throw shooting by OpenPose. So OpenPose is essentially a image processing technique for developed by Carnegie Mellon, CMU. In essentially, they use this one to be able to collect data points for a person to be able to determine like the skeletal structure of a person by training a huge amount of data set so that you don't need to use special equipment such as Kinect, which contains a depth sensor and a camera sensor, as well as a bit of machine learning to be able to detect the skeletal framework of a person or the kinematic data. So with OpenPose, you just need to use a video or an image, and it can immediately be able to determine the kinematic points and data of that image. So for this work, they essentially, of course, focused more on the free throw shot. They also applied time series data, a bit of posture analysis as well, and their participants are mostly from the basketball club team and exchange students from their basketball community. So again, this is for OpenPose. It's essentially, again, a real-time multi-person system for key point detection. And in this case, as we can see in the image or the GIF, you can see individuals as well as their kinematic points running through their face as well as hands through OpenPose. No? So for the idea of the work, this is a picture of one of the proponents testing out the OpenPose in the laboratory to be able to see if OpenPose can function properly in terms of this study, where it can obtain the corresponding kinematic data that is needed for the work. So the idea is that we would like to collect the data from a person at a ready state up to a shooting state to be able to determine the entire shot process and then overlay the kinematic data into essentially a single image. I will see a clearer picture of that image later. But the idea here is that the overlaid image would contain the start to finish of the shot process to be able to understand if hopefully if there are some relationships with regards to how a person prepares as well as shoots and then performs a follow through with the shot. So for the research opportunities for this work, we would like to, of course, determine the differences in the basketball shooting pattern because as we have observed, there is a familiar shooting pattern in this case by professionals, but there are some individuals who have some familiarity as well as preference with regards to different kind of shooting patterns. So we'd like to be able to understand more of these things as well as to maybe obtain more information with regards to which shooting patterns are the best shooting patterns in terms of the number of shots produced as well as misses. We also look at the posture difference of amateur players, compared them with professional players. Also look at the, of course, data obtaining from different setups. Could be from a smartphone, webcam, or even just a video obtained from the internet. And the idea with this one is that it's another opportunity to use the overlaid kinematic points to generate images for training instead of just using the points, angles, and lengths of the limbs and structure of a person. So with this research opportunity, the objective of this work is to implement various machine learning techniques to determine the patterns of basketball shots through the use of course, shot and motion data obtained from videos. So to start off, we essentially implemented data collection. Again, this is an ongoing work, so we are still collecting more data from some participants, but we'll gladly show you the results of our initial findings. So the idea here is that we ask the participants to essentially record 10 free throw shots as well as 10 three-point shots. Some shots, of course, for basketball, if you are familiar with the sport, they perform the shot with a jumping or a jumping and falling motion, which are essentially depending on the comfort level of that person in the shot, in making the shot process. So there are many kinds of patterns and techniques in how they perform shots. So essentially, you wanted for them to collect just free throw shots, since this is a more controlled action and position, as well as the location of performing this one is only at a single point. And then for a three-point shot, the distance to the ring is essentially somewhat similar for all the positions for a three-point shot. So we wanted to collect 10 data for each one so that we have a better understanding of these data, as well as we ask the participants to label their shot if they performed this shot and if it actually became a hit or a miss. So it's what we're going to be using for labeling of our data. So these are some examples of our participants that we asked to record themselves performing the shot process. So as you can see, some of the participants only used one arm for shooting, while some participants focuses on using both and not having a follow through with just a single arm raising up. As well as you can see here with this data is that at the center, there are some participants who had their camera too close. Therefore, OpenPose was not able to collect or correctly categorize or pinpoint the positions in the limbs, which makes it more difficult for the data set. Okay. So for some of the tests as well, OpenPose has a difficulty of detecting the different points, such as in this image at the bottom center, wherein the left and right limbs or the legs are essentially categorized both on the right hand side, as well as there are some difficulties in categorizing the arm. Okay. So with this one, we do have a lot of noise as well as some issues with regards to using OpenPose, which is why we had to remove some of the data that we have collected. So this is an example, or these are some examples for professional shooters. And in this case, we collected some of these from images or videos rather from the internet, such as through YouTube and other open source video communities. And in this case, as you can see, there are some shots or some recordings wherein the individual is essentially angled differently compared to other individuals. Like here on the top portion, we can see an individual performing the shot process at, of course, facing to his left-hand side, while on the other side, the individual is now facing on his right-hand side. So the left-hand side is closer to the camera. In this case, there are some difficulties with regards to using images or videos from the internet, since it is a less controlled environment. But that is one of the challenges that we would like to try to address in this study as well as we go along with it. So overall, as of the moment, for this presentation, we had a total of collected data. For the free throw, we essentially have 8 participants, totaling with 10 shots for free throws, for free throw shots. So that's about 80. However, only 6 participants were used, since again, some of the data were actually not captured perfectly. And we don't want to introduce that noise to the data set, else that we may have a lot of issues with that one. For the 3-point shot as well, because of the distance, there have been a lot of difficulties with respect to OpenPOS detecting the correct limb positionings of an individual. That's why only out of 9 collected shots, only 5 were used. For the online data set that we essentially obtained from videos from the internet, we essentially obtained 2 free throw shots as well as 5 3-point shots. So for the pre-processing of this work and how we perform the methodology is from the video. We essentially collected them, and thankfully the videos are all in 30 FPS. So when we so the first step here is that we convert the videos into frames through OpenCV, so that we can essentially get frame by frame the entire shot process. Next is, once we have the extracted frames, we now perform feature extraction, which allows us to extract the different points using OpenPOS. It's actually just 17 points, no, through the library that we used in order to obtain the kinematic data of an individual. As you can see here, we have the extracted frame. We mapped out the skeletal points, and then we just obtained the XY coordinates as well as the Z coordinates, giving us this distance, because OpenPOS also provides the Z index. However, for this work, since we did see a lot of errors or some noise with regards to the Z axis, we no longer continued using the Z and just focused on using XY. So here are the 17 points that we are able to obtain. We used it to the TensorFlow post estimation library to essentially get the XYZ positioning of the individual with the corresponding data points. Next is here is essentially the idea that we can now obtain the data points, as well as we can also create a data set through the kinematic overlay, which is the image overlay. So in this case, we wanted to explore the performance or the results as well of using just the time series data points, compare that to a kinematic overlay. If there's a relationship with both data, or if one kind of data set is better than the other. So for the traditional approach using the time series data set, data points, of course, follow the process of cleaning and transforming the data, performing time series, as well as splitting it to train and test before running it in a machine learning algorithm. So we essentially follow this process to remove the NAN or the errors from the feature extraction, normalize, implement scaling, as well as to remove outliers. So this just shows you some of the results and how we essentially removed it. So for the non-values, we literally just removed the frames. And then we essentially implemented scale transformation and then normalization. And then we implemented time series, because similar with time series works with regards to videos. In this case, a video may have multiple frames. And in our case, a shot may be done in a few frames or a lot of frames, or a long period of time or a short period of time. So since these time frames are different for each individual, we essentially implemented a moving average, computing for the min-max average, essentially, with a window of the focusing on the beginning of the shot, the middle of the shot, and the end of the shot, with by dividing the total amount of frames by 3 to obtain the start, middle, and end of the shot. So over here is essentially the computation sample row we have obtained, showing the X as well as the Y for the min, max, and average of each of the points. So that is for the first data set with regards to the traditional data points using the kinematic points as well as angles and length of the limbs and distance between each point. Now for the other data set, the second data set, focusing on the kinematic overlay. Again, we're focusing on overlaying the kinematic data of all the frames of a sample. And in this case, we have we used alpha to determine the difference in time, and we also colored the limbs for, of course, for just some qualitative detection if the data collection or the feature extraction was correct. This is an example of the results that we obtained from the kinematic overlay. As you can see, there are some samples that are very noisy, such as this one. And for some reason, with the Windows computer, it actually represents some of the images with a black background. But if you actually open the image, it's still just white. It's just probably a Windows error for this case. Some of the images are also quite confusing, but some of the images are quite clear with regards to how the shot process was created. But this is one of the challenges that we wanted to explore. So for the initial machine learning, we essentially performed, again, in two different techniques for the traditional data points as well as the generated image. So since this is only the start of the work, the initial work for this study, we essentially used SVM as well as for the data points and CNN for the image data set. So for SVM, we essentially just tried to run the data set with this one, and we essentially just resulted with very, very low accuracy. So we're still trying to explore the time series options and implementation for this one, hopefully improving the accuracy as we collect more data as well. For the CNN testing, we essentially used Inception v3 model and trained from that one. And we actually received a quite high amount of accuracy over here. So this actually shows us a bit of promising results with regards to using the kinematic overlay. So we wanted to, of course, improve this one. But maybe the future implementation for improvements for here is to not use Inception v3, but actually just have our own CNN model to explore the possibilities for improvement. So just some conclusions, recommendations with the initial work is that the current results are, of course, inconclusive at the moment because we're still actually trying to run a lot of tests and modify the time series processing in this one to hopefully improve the data. But the CNN results and the kinematic overlay looks kind of promising as since it actually shows us the entire shot process from start to finish in, of course, the entire image. I want, of course, to increase the data set as well. Again, use simple CNN. Maybe improve the time series by implementing windowing. So instead of just 33%, just to go with start, middle, and last, we essentially go with maybe 10% as well. We'll try out more machine learning algorithms as well as we may implement, or we would like to implement a fine transformation, focusing more on scaling, rotation, and translation as well to normalize the data point locations. Because in this case, the images or the videos are taken from different angles and positions as well as distances. So we'd like to normalize them first before we implement the tests again. So thank you, and that's pretty much it for my presentation. Do you have any questions?
Okay, thank you, Fritz. We'll be entertaining questions from the panelists and the audience. There's a question from Professor Numao. In the case of SVM, it seems that the features are not useful.
Actually, Professor, that's actually correct. It's also one of our observations as well as the recommendations of the panelists. As of the moment, since we're just using the data points, it's not very intuitive. So you're actually correct with that one. We'd like to improve that one by adding more information with regards to the angles, the limb length, as well as more information in regards to the shot process in itself. So we'd like to perform more feature extraction to also help the SVM better see the idea of the shot and not just look at just simple data points. So thank you for that comment. We'll try to improve on that one.
Okay, thank you again, Fritz. We'll be proceeding to the next presenter by Miss Anne Lorelei Avellino and others on designing an immersive VR application that uses collective memory for dementia patients in the Philippines. You may start. Thank you.
Good afternoon, everyone. I'm Anne, and in behalf of my co-authors, I am presenting our paper entitled Designing an Immersive VR Application Using Collective Memory for Dementia Therapy. The main proponents of this work are from the Service Science and Software Engineering Laboratory of the Department of Computer Science in UP Diliman. However, this is also a joint research involving different affiliations from UP Manila, UP Cebu, and Head Start Business Solutions in Quezon City. So, when we talk of dementia, what usually comes to mind is the idea of old people being forgetful, right? As given here, dementia is not really a single disease, but it is a term that covers a wide range of medical diseases and conditions. It is specifically a group of symptoms mostly characterized by decline in memory or memory loss, in language, in problem solving, and other thinking skills that affect a person's ability to perform everyday tasks. And the other symptoms are also listed here on the slide. So Alzheimer's disease is the most common disease associated with dementia. According to a 2018 journal article authored by a group of fellows from the St. Luke's Medical Center in Quezon City, the Philippines is experiencing a rapid demographic aging, and with it, the dementia epidemic. According to the paper, because of the high prevalence of risk factors associated with dementia, the Philippines can be considered a high-risk population for developing dementia. However, here in the Philippines, dementia is not really recognized as a major public health concern, and the research into dementia is generally lacking. This is unfortunate because most types of diseases associated with dementia have no cure. When one has dementia, in most cases, there is no cure that can stop its progression. And here in the Philippines, when one has dementia, treatments are only limited to drug medication and home care. So you can see that there is little development towards other potential ways of treatment and rehabilitation. In recent literature, there have been efforts to use VR technology as a potential tool for therapy. It has been proposed for many types of therapy, including those related to dementia. As compared to traditional therapy, the use of VR has a lot of advantages. For example, the equipment used in VR can be reused. In addition to that, it can be designed to be more engaging compared to traditional therapies that may be repetitive. It can be used not just in clinics, but also even at home. So this can be very helpful for patients in rural areas. In this work, we designed an application that is specific for Filipino patients that are diagnosed to have mild to moderate dementia. Our goal is to create an immersive VR application that will act as a supplementary therapy for elderly dementia patients. The main objective of this application is to use the concept of collective memory to slow down the decline of memory and provide relaxation and enjoyment to the patient. The concept of incorporating collective memory is a feature that makes this potential application distinct from other existing VR applications for dementia. But why the notion of collective memory? So one of the existing and usual therapies used for patients with dementia is the so-called reminiscence therapy. In reminiscence therapy, sessions could be held either individually or by group, and they are conducted such that past memories are discussed, with more emphasis on the positive memories. So there have been several literatures showing that the effectiveness of this technique, that not only does such therapy aid in cognitive function, it also promotes happiness to the patient and reduces depressive symptoms. Reminiscence therapy, patients' memories are recalled from their youth and early adulthood, that's around 10 to 30 years of age. The concept of reminiscence bump states that memories from this time of their life are better recalled. Most VR applications for dementia have already used elements from different forms of therapy, game therapy, sensory therapy. So how about reminiscence therapy? Can we incorporate elements from reminiscence therapy for VR applications? The thing is, memories are personal and user specific, so it may not be a trivial task to incorporate such form of therapy for applications that are intended for multiple users. Fortunately, we can use the concept of collective memory. So the concept of collective memory emphasizes that the society can directly affect which memories are more remembered. Using this concept, we can essentially incorporate societal elements and include different cues and artifacts that can trigger memories that are better recalled. For our application, we thought of incorporating the concept of collective memory by including pop culture references in the Philippines in the VR environment. So considering that dementia usually occurs in people that are above 65 years old, and that elderly people tend to remember memories in their life from 10 to 30 years of age, according to the concept of reminiscence bump, we specifically consider references specific to the Philippines setting from 1960s to 1980s. What was the Philippines like for the middle class in the 1960s to 1980s? Here are some of pictures of houses, appliances, food and drinks during that era. So given here are the specific features we want to include in the VR application. So there's personalized collective memory, there's a patient profile for each user, there's an interactive environment, a relaxing scenery and relaxing music, and some cognitive stimulating activities. So aside from the use of collective memory, we also want to include features from existing VR applications that also make use of other forms of therapy. Thus, for the other items, we will be adapting techniques and concepts from existing VR applications. Here we present the design of our target VR application. Since the application is considered as a supplementary therapy, a therapist or a caretaker is assumed to be present while the patient engages in the application. As given in the figure, the user wears a head-mounted gear and sits on a chair while the therapist gains a preview of the VR environment seen by the user here in this monitor. Applications will start with the main menu. In the main menu, a user profile can be created or loaded. Each profile stores the following: a generated unique ID, the personal details of the user, such as their name and age, personal images they want to use within the game, and their saved progress and settings. So a user can upload their own images for a more personalized experience. It may be photos of the past, or maybe photos related to them personally, such as a close family member, their favorite pet, or an item with sentimental value. These images will be displayed within the virtual environment and used for the minigames in the VR application. So once the profile is set up and selected, the user can now enter the virtual application. These are the key details for the virtual application. First-person navigation and interaction. The application will be using a first-person point of view where the user can look around and walk around the environment using a fixed set of controls. The second one, relaxation features. We basically want to incorporate sensory therapy through the use of soft filters, of relaxing scenery, and soothing background music while the user navigates the environment. The design for the virtual environment. In this slide, you can see the top view of the virtual environment. It is mainly composed of a home with a garden backyard. This house is designed based on an average middle-class Filipino household in the 1960s to 1980s. It consists of a sala or a living room, a dining area, a leisure area, and a receiving area. So those are pictures of those rooms. Dining and receiving. The garden backyard. Next up is collective memory elements. So the food and items during the 1960s and 1980s that are modeled in the VR environment and located in different areas of the house. Familiar pieces of furniture, such as common house paintings, tables with picture frames, is included in the home area. So the television in the home area could also play commercials during the 1960s to 1980s. The user uploads their own image. It will be displayed around the virtual house in the form of picture frames, the photo albums. Interactions. Object interactions would enable the user to perform usual household routines. For example, the TV in the sala area can be switched on or off or changed channel. Upon switching it on, maybe famous TV shows, commercials, or news from the 1960s to 1980s will be played. The user can also interact with the radio in the leisure area, such as turning it on or off. And when you turn it on, you can hear famous music from the year range mentioned. Are examples of possible interactive objects in the virtual environment. Lastly would be the mini-games in the virtual environment. We selected 4 mini-games that are associated with memory, both short-term and long-term memory recall. We have a light pattern memory game. A sequence of lights are played and the user must repeat the same sequence. A matching game. A puzzle type game. Pieces of a painting and put it back together. A family tree matching game that jog their memory about the user's connections to their relatives. So the interactive objects and the minigame mentioned could be scattered around the virtual environment. So for example, in the leisure area, we have the photo album, the family tree matching game, or say in the sala, there's a television that can trigger the light pattern memory game. So yes, there are also other interactable objects scattered in the dining room and the receiving area. And maybe in the garden backyard, there could also be a planting game just for fun. We currently have a partial implementation of the VR application mentioned. It's made using Unity and the objects in the house were modeled using Blender 3D. The equipment we've been considering for this VR application are as follows: the generic VR headset and a handheld controller, or Oculus Go, or Oculus Rift S. Testing. Preferably, the testers are healthy people with a background on the experiences and needs of a person with dementia, so that they have a context on what they should be looking for in the application. Each testing session would be around 25 to 30 minutes with the testers signing a waiver. They would have to make their own profile and they'll have to explore the environment for 3 to 5 minutes and try each minigame for 5 minutes each. And then they can answer the user feedback form to to give their comments on how the experience was, how helpful it would be to someone with dementia. In this work, we presented the design and test plans for a VR application that incorporates multiple kinds of therapy: reminiscence therapy, sensory therapy, and game therapy. This study also provides a preliminary work on the use of collective memory in a VR application. For listening, are there any questions?
Okay, there's a question from Professor Shinya. So was VR sickness a problem during the experiment in its application? 25 minutes, no problem.
Okay, regarding VR sickness, we were actually trying to determine a certain amount of time that might be better for, what do you call this? For each session, I guess, of VR. There are papers about that, and I recall it's around 15 minutes before you have to take a break. For the testing I mentioned, I said it was around 25 to 30 minutes. But that's so they can fully explore the environment. So yes, VR sickness is a possible problem that should be addressed.
Thank you. There are any other questions from the audience? Okay, so from Professor Numa, how will you evaluate the results?
Of what exactly? Of the testing?
So my question is because this is you have to improve the inertia or other. So I think you have to do some medical experiment for evaluating this.
Yes. Okay.
So it can be very hard, but do you have any good idea for that? It takes a long time to evaluate, maybe. I'm not sure. I'm not a doctor, so I don't know. But I'm very interested in this.
Hello, Professor Numa. Maybe I can answer the question. Right now, this is actually an ongoing project, so we have not yet proceeded with the testing part, also due to the current situation. There is a plan to proceed with clinical testing, although that's not yet done. We are collaborating with people from UP Manila, doctors, to proceed with that, although that's not yet done.
So do you have any intermediate evaluation before consulting with doctors? For example, checking some mental states or something?
Yeah, right now, the initial plan, there's already a partial implementation of the work, but it's not yet fully implemented. So once that is fully implemented, we can proceed to testing first with healthy patients in order to get feedback. Also apply tests from previous literatures, tests done in previous literatures, and then proceed with the clinical testing afterwards.
I see. Thank you.
Thank you, Professor.
Are there any other questions from the audience and the panel?
I am here. I'm just curious, is the work intended to be part of a therapy program?
Yes, ma'am. It will act as a supplementary therapy.
Okay, thank you.
Thank you for the question.
Okay, we can entertain one more question before we have a scheduled break.
Yes, good afternoon. I have a question.
Yes, go ahead, please.
Yeah, first, I really appreciate the presentation of Anne, Paula, and Paul. I think the research is very interesting. I saw some point that there's 25 minutes for the dementia activity, or the VR will be used for these 25 minutes. Yeah, here. A testing session will be conducted in 25 to 30 minutes. May I know why 25 or 30 minutes? Like, is it good enough to measure or to retain the memory? Thank you.
To be exact, the 25 to 30 minutes is to make sure that the tester would have enough time to check everything out in the virtual environment and evaluate it based on what they see or feel about it.
Like, are there some studies to show that 25 minutes is really appropriate time, including your test, your mini games, and others?
Upon us that it would be around 25 to 30 minutes per testing session.
Okay, thank you very much.
Okay, thank you again, Anne, and all the presenters for this first session in the afternoon. We'll be proceeding with our break and we'll be resuming the sessions at 4:45. So thank you again and see you later.
Thank you, John. Congratulations, John.
Hello, everyone. Can you hear me? I hope you all can hear me. Okay, we are down to our last session. So let's now continue with the conference. My name is Rochelle Wayong, and I will be your moderator for this last session. So we have 4 remaining presentations. Just a reminder for the presenters, you are given 20 to 22 minutes to present your paper. And then after, there will be a 3 to 5 minute Q&A session. For the attendees, you can...
Okay, for our next session, this is our last session. We still have 4 presenters. May I introduce our moderator? By the way, let me thank our previous moderator, Justin Jan Villar. Dr. Justin Jan Villar is from the Modeling and Simulation Laboratory of the Department of Computer Science. And now, may I introduce Dr. Rich Anwayong from the Service Science and Software Engineering Laboratory of the Department of Computer Science, UP Diliman, who will moderate the next session. Rich?
Yes. Hi, Sir Jean. Thank you for the introduction. I was actually talking earlier. Just to recap what I mentioned earlier for the presenters, 20 to 22-minute presentation and then 3 to 5 minute Q&A. For the attendees, you can ask your questions by typing it in the Q&A box. And for the panelists, you can unmute or type your questions in the chat box. So let's start the session with the first presentation from UP Diliman and Philippine Genome Center. The title of the talk is Dominating Balanced Protein Interaction Networks in Cancer. So the authors are Rihanna Patricia Cruz et al. So is the presenter ready? Okay. So for the presenter, kindly unmute and proceed with the presentation. Thank you.
Good day. I am Hannah Magno, together with Rihanna Cruz from University of the Philippines, Diliman, and our research is about dominating balanced protein networks in cancer. Our goal is to find the driver proteins in a network to know what mutation of genes or proteins cause diseases, especially in cancer. Given a network, how do we identify the driver proteins? Proteins regulate with other proteins and is referred to as the protein regulatory networks. Proteins interact in various ways, and we denote the positive interaction when a protein upregulates another protein and when it increases a cell sensitivity to the other protein. A negative interaction is when a protein downregulates another protein and decreases its sensitivity. Protein-protein interactions can be represented as a graph with proteins as the nodes and the interactions as the edges. Specifically, we represented the protein regulatory networks as sign graphs. A sign graph is defined as a directed graph where each edge has a positive or negative sign. The sign of the path is the product of the signs of the edges along a path. For example, in a path from vertex 3 to vertex 8, the sign of the edge is -1. From vertex 8 to vertex 9, the sign of the edge is -1, and from vertex 9 to vertex 4, the sign of the edge is -1. And by multiplying all the edges, the sign of the path is -1. Another example in a path from vertex 0 to 9 to 4 to 5 and to 6, the sign of the path is simply 1 by multiplying all the edges. Next, a sign graph is said to be a balanced sign-directed graph if the product of all path signs is positive. In this graph example, all the signs of paths starting from vertex 1 is positive. So this graph is a balanced sign-directed graph. Preliminaries for dominating sets. A dominating set is a subset D of vertex set V of G, where every vertex in V not in D is adjacent to at least one vertex in D. This graph, the set 1, 3 is a dominating set. It is because every vertex in the graph is adjacent to vertex 1 and 3. Finally, the MCDS or the minimum connected dominating set is a connected dominating set of G with the minimum size. In this graph, the set 1, 2, 3 is the MCDS for it has the minimum number of connected dominating set that is adjacent to every vertex in the graph. The shortest path tree is the tree of shortest paths in graph G and rooted in vertex V. We applied an algorithm to balance the network. To model gene regulatory networks, we use sign-directed graphs because signed edges may model their regulatory interactions. Negative edges model downregulation, while positive edges model other interaction types. We use the shortest path tree to model our gene regulatory networks considering Occam's razor, which tells that if we are given multiple solutions, we must choose the simplest solution. With gene regulatory networks where multiple paths may exist from any protein to another, this leads us to select the shortest path between the two proteins. Our algorithm requires a root node or set of root nodes to model the regulatory function of driver proteins. The relaxed definition of balance in a given network is that it is not completely balanced 100%, and we only balance paths to leaf nodes. The input of the balancing algorithm is a sign-directed graph in a set of root nodes from set V. And the output is a balanced shortest path tree, T of G, rooted at a set of root nodes.
The next algorithm we used in our study was an algorithm to find the minimum connected dominating set of a network using topology-based heuristics. For our methods and data, we used the Senior Dataset, which is an open-source dataset of protein-protein interactions in the human system, which we divided into test sets, which we implemented our algorithm on, and validation sets, which we compared the results of our algorithm to. From the driver proteins we found, we performed pathway analysis, and from the pathways we got from here, we performed a literature survey to see how many of these pathways actually did have a link with cancer. What we found was that our driver proteins were more topologically significant than the control groups. Here we can see that their betweenness centrality had a higher median range. Their degree centrality also had a higher median range. And they had a comparable consensus with positive controls from other methods. We also found that the driver proteins we found for each cancer enriched pathways with statistical significance that about 80% of the time have been linked with cancer. Here we can see that that's about 10% more pathways than those not enriched by our driver proteins. So from these, we validate that sign graphs can model the regulatory functions of protein networks, and that minimum connected dominating sets and sign graphs can be used to identify some driver proteins of cancers comparable to other computational methods, and that when modeling disease networks, it may be best to incorporate some a priori knowledge. Thank you for listening.
Thank you for that presentation. So the floor is now open for questions from the audience. I am now checking the chat box. So no questions so far from the Q&A box and the chat box. So maybe I'll start with the questions. Hannah, I'm just curious. Are there other dry lab or algorithmic based approaches to finding driver proteins for cancer? Hello? Am I being heard? Hello?
Yes, yes.
Yeah, so that is my question for Rihanna and Hannah.
Hello.
Hi. Hi, Rihanna.
Ma'am Rich. Meron po, marami, there are methods, but not all of them are network-based. Like, we based our paper somewhat on another paper, which was looking into the controllability of a network, but there are other not network-based methods, like machine learning, where they try to look at the features of the proteins to see if there's any like pattern or system to what would make a protein influential in all of the sets of proteins. So it's not just dominating sets that are a common method. It's driver proteins.
But what is distinct is that you were able to model it using graphs, right?
Yes, using graphs and the dominating set, the connected dominating set and sign graphs.
My other question is, I would like to know the feedback from your domain experts. I see that there is one author from the Philippine Genome Center. So my interest is I want to know if they are interested in probably using this to identify potential driver proteins.
The feedback was, this was actually a continuation of another Philippine Genome Center study, where they looked at the proteins only for breast cancer. So we continued it with breast cancer, ovarian, and pancreatic. And their feedback was that some of the proteins that we found were familiar, like they were associated with cancer or cell growth. So that's the biological implication, something interesting in the biological side that they found. I'm not sure if they're going to pursue it right now because they're focusing on COVID efforts.
Yeah.
But maybe in the future.
Yeah, and also it's an ongoing research also in PGC. Yeah. For my last question is what is the motivation for using minimum connected dominating set for identifying driver proteins?
Because in our lab, our advisor already was using minimum connected dominating set for finding the driver nodes of like scale-free networks, not not biological networks. So we thought it would be interesting to try to apply that to a biological network. And we saw that the Genome Center was also interested in that. So that's why we applied the minimum connected dominating set to this driver protein network.
Okay, thank you, Rihanna. Are there other questions? Okay, so if there is none, we are going to proceed with the next talk. Okay, so for the next talk, the title is Analyzing the Effects of Subjectivity on Classifying Emotions in Music. So the first author is Fritz Edron Kalimag. There are a lot of authors. Is the presenter ready?
Hello, yes.
Okay. Hi, Amir.
Share my screen.
Okay, I can now see your slides. Kindly proceed with the presentation. Thank you.
Okay, thank you. So, good afternoon, everyone. I'm Emir Mendoza, and I'm here with my co-presenter, Graciel Nuncio. And today we'll be presenting our study entitled Analyzing the Effects of Subjectivity on Classifying Emotions in Music. So first, here is our outline of the content that we will be presenting today. And we'd like to start with what is music? Essentially, music is simply a combination of notes that, when sequenced together, can create harmony. And through harmony, there is expression. And music has been known to have the ability to embody themes through expression. And to get on with what exactly is a theme, it is an attribute, descriptor, element, or concept. And a theme is subjective in nature. Therefore, it is difficult to classify music accordingly. A theme can be used to capture musical emotion. And to get on with what exactly makes up music emotion or a musical theme, we look into the high-level features and low-level features of musical pieces. High-level features can consist of tempo, mode, and arousal. These are known as human interpretable descriptions to music. So when one person listens to a musical piece, they can determine if the tempo of the piece is slow or fast, for example, and so on. And for low-level features, these focus more on the data of the musical piece itself. This is basically the audio signals, which contain different information of a musical sample. And with that brief introduction, we delve into the research questions that this study aims to answer. First is, how do classifiers respond to the subjectivity of emotions in music? Second is, for each emotion, how do the classifiers respond to the subjectivity of the labels? And lastly, how do the classifiers handle the subjectivity of emotions in music across several experts? And to answer these research questions, here is our methodology. So first, we started with data gathering. We collected samples of specifically Chinese children's stories on YouTube, and we pre-processed these samples by removing the narration from said stories so that we will end up with simply the background music, which is what we are focusing on. And next, we moved on towards feature extraction. We used an open source software called JAudio to extract the low-level features as mentioned earlier. And then we moved on to expert validation. So we interviewed a couple of experts which would have verified the labels of our samples, and they helped us determine the high-level features used in each sample. Afterwards, we proceeded with model building. We trained classifiers, which basically would label the music samples. And afterwards, there's model fine-tuning and validation. Lastly, results and analysis. So for the experiments we performed, here's the outline. We'll be discussing the general experiment setup, the algorithms that we used, the hypotheses, and lastly, the summary of results. So for our general experiment setup, we used 6 emotions for this study. And these are respectively calm, cheerful, bravery, fearful, love, and sadness. And we ended up with 3 data sets. As you can see, the first data set is imbalanced. So we attempted to circumvent this by using random oversampling and SMOT to end up with a balanced data set, totaling to 3. For model selection, we used the sklearn library of randomized hyperparameter search to find the best possible parameters for our models, and we used 5-fold cross-validation. For normalization, we used min-max scalar. And due to the circumstances of the COVID-19 pandemic, not all of our samples were able to be labeled by a musical expert. And so we decided to use a semi-supervised learning approach wherein the samples that were labeled would be used to train and label the remaining samples that were not labeled, as mentioned. And we ended up with a total of 419 musical samples. Also, we used 69 total musical features after using variance threshold for feature selection. And we have 22 samples in our validation set. So as you can see here, this is the training set after we use semi-supervised learning. It's worth noting that COM has the most number of samples and Love has the least. So for our musical experts, we had a total of 3 musical experts who had a long musical background, and each of them had formal music education. And we performed 2 main experiments for this study. The first is we trained our classifiers using the labels of a single expert only. So the 419 samples labeled by only one expert, and we compared it to the consensus labels, which basically is, for example, the 3 music experts all agreed that a certain sample embodies cheerfulness. That is its consensus label. And here are the algorithms that we used in this study. Yeah, these algorithms were used for our classifiers. And for the music features mentioned a while ago, we have tempo, mode, arousal for the high-level features. Tempo had 2 options for the music experts to label, which are slow and fast. Mode had major, minor, and dissonant scales. And arousal had low and high. For our low-level features, there are too many to list in this presentation, but here are some examples of some of them that were extracted. We have MFCCs, compactness, LPC, root mean square, and so on. So for the remaining part of this presentation, my co-presenter, Rachel, will continue.
Thank you, Amir. So in order to answer our research questions, there are 3 hypotheses we laid out for us to support or deny. First, if there is a significant difference in a classifier's performance when trained on a single expert opposed to consensus labels, in order to see how subjectivity affects the performance of a classifier. Second, for each emotion, there is a significant difference in a classifier's performance on a single expert label opposed to the consensus labels to see if there is a significant difference on the performance of the classifiers per emotion. Then lastly, to see if the subjectivity handles emotion in music across several experts, we test if there is a significant difference in a classifier's performance across the labels of each of the 3 experts. For comparing the results of various sets of experiments, we performed statistical tests of significance with our significance level set to p-value less than 0.05. 2 main experiment setups were conducted. One where the classifiers were trained on the labels from a single expert only, and one where the classifiers were trained on the consensus labels. For each set of labels, several classifiers were trained, one for each combination of algorithm, dataset, and emotion. This means each classifier would be a binary classifier that identifies a single emotion. Here is a summary of mean of our performance measures of the 2 experiments. experts were anonymously labeled as E1, E2, and E3. We reported the mean precision, recall, and AUC ROC scores of each group of trained classifiers. The maximum values are displayed in bold while the minimum are underlined. It is interesting to note that love had the highest recall, while sadness had the highest precision in AUC ROC mean scores. For hypothesis 1, a two-tailed student's t-test was done to test whether there is a significant difference in a classifier's performance when trained on a single expert labels as opposed to the consensus labels. Specifically, there was a significant difference between the means of the performance measures of the classifiers trained on single expert labels versus those trained on the consensus labels. These test results indicate that, when considering all emotions, the classifier's performance was not greatly affected by whether the ground truth labels came from the opinion of a single expert or a consensus. This also implies that, in general, subjectivity does not have a strong effect on the performance of a classifier. For hypothesis 2, next slide please. Similarly to hypothesis 1, to test whether for each emotion there is a significant difference in a classifier's performance when trained on a single expert labels as opposed to the consensus labels, a two-tailed student's t-test was performed. For this test, however, the classifiers were segregated into 6 groups, one for each emotion. The precision of calm, fearful, and sadness performed better for the consensus labels. For this measure and these emotions, the results supported the hypothesis. Similarly, the classifier performed better in terms of AUC ROC scores using the consensus labels for bravery, fearful, and sadness. Likewise, it also supported the hypothesis. And that you can see that these test results indicate that some combinations of measures and emotions are more sensitive to subjectivity than others. Lastly, for our third hypothesis, we performed a one-way ANOVA test across 3 populations. These 3 populations were the groups of classifiers trained on the labels of each of our 3 experts. For precision, we concluded that there is no significant difference in the mean performance across all 3 sets of classifiers. However, if you look at the AUC ROC scores, here is a significant difference in the mean performance across all 3 sets of classifiers. This tells us that, in general, the classifiers were able to learn consistently well relative to one another, regardless of the source of the label, but some of the classifiers may be responding to experts who are more consistent in identifying emotions in music as compared to other experts from a computational standpoint. These results would indicate, though, that some trained classifiers still perform better if the annotator of the emotions is more consistent with how they label their emotions. In conclusion, for some of the emotions, the classifiers respond to the subjective nature of some of the ground truth labels, but in general, the algorithms we chose are robust enough that subjectivity does not have a significant effect on its performance. Now we're going to discuss our recommendations for future work of this research. So first, our first recommendation would be to improve upon gathering of the music samples. In this case, because some of the finals music samples ended up having white noise that would affect the emotion of the music sample. There were also music samples that ended up being labeled as a broken sample, as its music content was omitted in the process of cleaning the data. With that being said, we suggest using a different approach in removing the narration for cleaning the data to avoid any of these previously said anomalies. Second would be the additions and modifications during the expert labeling phase. This is divided into 3 parts, with the first part being the addition of a middle range tempo during expert labeling. For we were advised by the musical experts that tempo isn't only restricted to between slow and fast. The music experts suggested to us that we give a range of beats per minute to determine what is considered fast tempo and what is considered as slow tempo. In addition to this, The addition of more musical experts to validate the data would also help in improving the data set for music samples that have been labeled differently by all experts are less likely to occur. Our third recommendation would be building a dataset that has a balanced number of samples for each emotion. Expanding the dataset might improve the performance of the model for future studies. Next slide, please. Thank you. And our last recommendation would be to look at other types of music to be sampled for music classification. We recommend this for our study was only restricted towards music in Chinese children's stories. And there are still other types of music that can be sampled, such as music from musicals and other forms of media. To recap, here are the important findings of our study that subjectivity does not have a strong effect on the performance of a classifier. Some combinations of measures and emotions are more sensitive to subjectivity than others, and some trained classifiers still perform better in the annotator of the emotions is more consistent if the annotator of the emotions is more consistent with how they label their emotions. Thank you very much for listening.
Thank you. That's actually an interesting presentation. And thus, we now have two questions. So one is from the attendees and another is from the panelists. So let's start with a question from Luis Del Rosario. Kindly unmute and ask your
Hello,
question.
can you hear me?
Yes, yes.
Okay. Hi, I'm Luigi from University of the Philippines, Diliman. Interesting paper. Um, am I correct? First, am I correct in understanding that the models you used mostly work with low-level features as opposed to high-level features?
Hello, yes, that is correct.
Um, yeah, and you also mentioned right that expert musicians are they use more high-level features to help them classify a musical piece into an emotion. And I think this is common actually for a lot of musicians also. Like for example, it's commonly known in music that harmony plays a big part in emotional response. Like the simple example of minor chords being sad, major chords being happy, and even a combination of more high-level features like harmony, rhythm, and timbre could yield completely different emotion than their individual components. Like for instance, a minor chord played very fast could be more of angry instead of sad, or like the use of a flat seven could elicit a brave or triumphant response, things like that. So I guess my question is, as you said in your recommendations, can you expound on how you would add more advanced high-level features like melodic patterns or note intervals? And what challenges would arise from this shift in focus, given that your data set is mainly composed of recorded audio?
So thank you for that question. So to answer that question, the main challenges that would be posed to us upon expanding these high level features is I think it's to determine exactly like specifically for children's stories kasi it's known that they are simple, which is partly the reason why we actually use them for this research. And I guess it would take more time with the music experts, and it would also help a lot that like if we get more musical experts to further verify these, because yeah, as suggested there will be a lot more combinations of said high level features, and if once we go into more complicated features, our methodology currently might not be apt for it. So we will further expound on that specific expert validation process.
Okay, thank you very much. Maybe a suggestion would be there are ways to extract high-level features from recorded audio. I think there's lots of research being done on that in music technology research centers in other places. So maybe if you want to expound on this research, you can look into that. Thank you very much.
Okay, thank you.
Okay, thank you, Luis. We have another question from the attendees. This is a question from Orven Liantos. Thank you for the presentation. I'm just curious on how you used the algorithms enumerated in this research. Are they put on a pipeline or did you use them separately to achieve your results? So that's the question.
Thank you again for that question. To answer this, we use them separately to achieve our results. Reason being, we use the common algorithms used in similar classification tasks, and then we compared them with related works so that we can have a baseline of our own.
Okay, thank you for that answer. Yeah, I think Orvin is already satisfied. So are there any other questions? So if none, let's thank the presenters. Thank you, Amir. We are now going to proceed to the next presentation.
Okay.
Let me just introduce you first. The next talk is entitled Load Reducing of the SAT Solving Contest Server by Delegating Execution to Web Browsers. So the authors are Osamu Miyazawa and Shinya Nishizaki. So I think the presenter is already ready to present.
Okay. Thank you for introducing me. Can you hear my voice and
yes.
Can you look at the screen? Okay.
Yes, I can see the screen. I can also hear your voice.
Okay. Let's start. Thank you for introducing me. My name is Osamu Miyazawa. I am a PhD student in the Department of Computer Science at Tokyo Institute of Technology. The topic of my talk is load reducing of the SAT solving contest server by delegating execution to web browsers. This research is being conducted in collaboration with Shinya Nishizaki, who is my research advisor. This slide is the outline of today's talk. First, I talk about the background and the purpose of this research. Second, I explain my proposed method. Third, I tell you the design and implementation of the system. Finally, I discuss my conclusions and future work. Now, let me start with the background and purpose of this research. What is the SAT solver? The SAT solver is a software for solving Boolean satisfiability problem. Then, what is the Boolean satisfiability problem? In the Boolean satisfiability problem, which is often abbreviated SAT, we find assignment of Boolean values to Boolean variables which satisfies a given logical formula. Here are two examples. What assignment satisfies the logical formula in example 1? If variable A or B is true, the first disjunction is true. And in the second disjunction, this disjunction is true if A is false, or B is false, or C is true. So, for example, A is true, B is false, and C is true. This assignment satisfies the formula. It is called satisfiable. Next, example 2. In order to satisfy the first disjunction, A or B must be true. However, in the rest of this formula, A and B must be false. So, no assignment satisfies for formula. It is called unsatisfiable. The third problem, known one of the NP-complete problem, has been used to make a polynomial reduction to show that other problems are NP-complete. Many combinatorial puzzles can be considered such problem. For example, Sudoku, 8 Queen, numbering, and etc. A conjunctive normal form, which is often abbreviated CNF, is a conjunction of disjunctions of logical variables and their negations. In CNF, logical variables and their negations are connected by logical disjunction. It is called classes. These classes are connected by logical conjunction. Dmax CNF is the standard format of CNF for such solvers. For example, the above CNF is represented as the Dmax CNF below. The first line represents the number of variables and lines. In this example, 3 is the number of variables and 2 is the number of lines. In Dmax CNF, Boolean variables are represented as numbers. In this example, the variables A, B, and C are represented as 1, 2, and 3, respectively. To represent a negation, put a negative sign on the number. 0 represents the end of line. Thus, in the Dmax CNF, A or B is 1, 2, 0, and not A or not B or C is -1, -2, 3, 0. The second and subsequent lines are connected by logical conjunction. Thus, in order to solve problems using such solver, we need to formalize the problem into a Dmax CNF. It is worthwhile to study formalization because formalization will enable us to solve a variety of problems using the such solver. So, I came up with the CNF coding contest. The purpose of this contest is to encourage participants to learn formalization. They learn how to formalize a problem in a CNF through solving puzzles such as Sudoku. This is a naive version of our contest system. First, a participant receives a question from the contest server. Second, the participant solves the question. In other words, he or she makes Dmax CNF and submits its answer to the contest server. Third, the submitted Dmax CNF is judged by the contest server. where the CNF is solved by the SAT solver. This naive system can cause DOS attack because SAT solving can be heavy task. Therefore, a malicious user may make an answer too heavy to verify and submit it to the server. High-performance servers may be able to deal with the attack, but such servers are expensive to maintain. So, the purpose of this research is design of low-cost contest server which can judge satisfiability. The design enables the contest server to have tolerance for DOS attack and save computing resource. Using this design, the contest system can run on low-cost servers. Next, I would like to propose two methods for DOS tolerant and low-cost servers. Proposal method 1. A server delegates SAT solving to the client. SAT solving may be a heavy task, so SAT solving is not done on the server side, but on the client side. To delegate the SAT solving to the client, we used WebAssembly. WebAssembly is a binary instruction format. By compiling code written in languages such as C and C++ with WebAssembly, a software is possible to run fast on the browser. And so, this is a system introduced delegating method of SAT solving. A participant solves a question, and he or she sends it to the server. It is the same as the naive system. Next, the server returns the CNF to the client with test data of the question. For example, in Sudoku question, test data of the question is an initial board of Sudoku. Then, the SAT solver runs on the client side and sends the result to the server. Finally, the server judges the result. In this system, the SAT solver doesn't run on the server side, so it doesn't burden on the server. Let me show you a concrete example of a CNF in the system. For example, in a Sudoku problem, participants create a CNF of the rules of Sudoku. The contest server then has a CNF of the initial board of Sudoku. And these are combined to create the entire CNF. And the client-side SAT solver solves the entire CNF. However, this system has a problem yet. In this system, the SAT solver runs on the client side. So, malicious users may solve CNF not using the SAT solver and tell a lie that he or she solved the CNF using the SAT solver. Therefore, we need a system to check if the SAT solver really solved the problem. This is a proposed method 2. The server inserts the client puzzle into the CNF delegated to the client. If the client solves the client puzzle correctly, the server trusts that the client is running the SAT solver really. This method is based on client puzzle protocol. This is a protocol against connection depletion attacks. In client puzzle protocol, the server imposes a mathematical puzzle to the client requesting connection. By loading the client puzzle protocol raises the cost of attack. A client puzzle could be a problem of arithmetic. For example, using half adders and full adders. We can build the inputs and outputs of an adder as Boolean variables and view the calculation of the adder as a logical formula. So, we could represent the adder circuit in DMAX CNF. We can make a client puzzle as a math problem with an appropriate load. This is the system introduced proposal method 2. Similarly to previous two systems, a participant sends DMAX CNF to the server. Next, the server returns the CNF, test data of the question, and a client puzzle. The search solver on the client side solves them and sends the result to the server. The server judges the result of the question and the client puzzle. Next, design and implementation. This slide explains the design of our system. A search solver runs on a client side. A CNF contains an answer of a question and a client puzzle. The code of the search solver and the CNF are sent to the client from the server. The code of search solver is a compiled code of Minisat on WebAssembly. The content of the CNF consists of a CNF representing an initial vote, a CNF of the rules submitted by a contestant, and a CNF representing the client puzzle. This is the implementation. First, I will introduce the implementation of the contest server. The hardware is a Raspberry Pi 0W. It has a CPU 1 GHz single core ARM 1176 JZF, ARM v6, and 512 megabytes RAM and 8 gigabytes storage. Linux kernel is 4.19.75 V7L+. And the OS is Raspbian GNU Linux 10 Buster. As our web server, we use Node.js version 10.15.2. Second, let's talk about the client-side implementation. Programming languages we used are JavaScript and WebAssembly to run Minisat. The search solver used is Minisat, version 2.2.0. We are reaching the end of the presentation. Conclusions and future work. In this research, we have designed low-cost server for search coding contest, which is resistant to DOS attack. As future works, there are two subjects. The first is about a client puzzle. It is necessary to adjust the processing load of the client puzzle properly. The second future work is that we want to apply our methods to other web systems. Okay, that's end of my presentation. Okay, let's look. Let's show you demo movie. This is a solving contest site. This is a sign-in screen. Okay. Enter user ID and password. The user sign in. And this is a questions list. In the demo, the user selects a Sudoku question. This is the Sudoku question screen. Above is an explanation of the question, and below is answer column. And the user inputs the answer to there. And in this demo, the user made such program and made a CNF of Sudoku rule. The user copies this and pastes it to answer column. And when click submit is clicked, this answer is judged. The answer is correct, so the system tells the user that the user can select answer again or return to the question list. Okay, let's answer again. Next, let's look what happened. Incorrect answer input to the answer column. This is incorrect answer. This is incorrect, so the system tells the user it is incorrect. Okay, this is the end of my presentation. Thank you for listening.
Thank you for the presentation. We can now entertain some questions. So we have two questions, both from the panelists. One is from Orvin. Very interesting presentation. Is it possible to send digital signatures to the client so that when a puzzle solution is sent to the server will be able to verify the result by checking the signature? So that's the question.
Thank you for the question. It is very interesting question.
Maybe that can be one possibility to explore.
I think that we can do it, but in this system, I want to check if the client is running the SAT solver really. So, sorry, I don't know about digital signatures. What?
Yeah. And I think I'm co-author. I think I'm not sure at the moment, but I think it's very interesting question, and we assume that the client is not make some kind of registration, and there is no share the key or some signature. So I'm not sure, but I'm sorry. I very thank you. Very interesting question, and so we would like to think about that later. Okay, thank you.
Thank you. And next question is, do you have any idea what kind of practical purpose your method can be applied to? We thought about it. For example, we can use this idea to web games, browser game. When we want to do execution on the client side, not on server side, we may be able to use this idea. Thank you. Any other question?
Thank you, Osamu, for
thank
the
you.
presentation. And if there are other questions, you can probably contact Osamu and Professor Shinya. Okay, are there any other questions? If there are none, we can now proceed to the last presentation. So this presentation is entitled MySQL Index Suggestion Tool. The authors are Alan Bautista, Nick Felnar, and Ligaya Figueroa. Is the presenter ready?
Hello? Yep, can you hear me?
Yes, I can hear you. So kindly share your screen and please proceed with the presentation. Thank you.
Okay, thank you. Thank you, Rochelle. Are you able to see my screen now?
Yes.
Yes.
Okay. So our project is called MySQL Index Suggestion Tool. So my co-authors are Nick Felnar and Miss Leia Figueroa. So me and Nick are colleagues, and we are currently studying in UP Diliman as masters in computer science. So our project motivation is that performance is a metric that needs fine-tuning on some of the parameters of an application. So deployed applications in production needs a way to analyze which fields can be indexed based on the load given to the system. So our aim is to create a tool that will analyze post-development queries sent to the MySQL DBMS and suggest potential fields that can be indexed to increase system performance. So there are other tools that is checking the performance of DBMS, but there are currently, we only see few for MySQL. So it's mostly other DBs like Postgre and other types of SQLs. So there are two types. So the one is detached and the other is fused. So for the detached one, the analysis is done without any intervention to the system. The input is a certain workload size or log queries. And for the fused, the DBMS is tweaked to gather more information during query optimization. This gives more insight as to how the DBMS actually executed the query. So we chose the detached type, and this is our architecture. So we have a load simulator that sends queries, and we use JMeter and Spring Boot. So it sends queries to the system that is also operating under Java and Spring Boot. And our test and our simulation in this project is for a local deployment only. And then when it sends the queries, we enable the slow queries logging in the MySQL DBMS. And then we have an analyzer that we created, and it fetches data from the MySQL slow queries. And then the analyzer will suggest potential new indices, and then will present which fields might be better for index use. So for our load simulator, so we use JMeter as a Java run load testing tool that can simulate user requests or queries. Concurrent threads can be created to run in parallel and try to simulate a real-world scenario of concurrent users accessing a system. And for our system, we experimented on a locally run Java and Spring Boot application that has around 100,000 simulated user data, created or generated using the random user generator. And then we saved it to our database, which is the MySQL. And then we allowed to query or find users by the first name, last name, and the email address. So some sample data can be found below. So the MySQL slow query, the database server from the MySQL registers all queries that exceeds a certain threshold for execution time. So when it's enabled, uh, it will be able to check which fields or uh, which fields in your table are running slow or have high uh, performance issues in the table. So for this project, we use the default, which is 0.1 seconds for the threshold of the execution time. So our analyzer, it uses the slow query logs and then filters the unnecessary data, then computes a score based on the general weighted average. So we use Java with Spring Boot since we are familiar with the architecture of Java and Spring Boot. And then the suggestion field score was filtered to accept anything more than one field score. So for the field score, we use this equation. So it's a general weighted average, and where apt is the average processing time of queries containing the field. And then frequency is the count, how many times it was used. And the observation count is the total logs in the slow query tool. So we use this because we don't want to consider or give too much weight to long-running fields, but it happens only infrequently. So we use the general weighted equation. So for the experiment, we have 4 scenarios. So the first scenario is load testing was done with high load for the first name with 1,000 user threads and low load for the last name and email queries. So with only 100 user threads each. So the rationale for this scenario is for experiment. This is to test if our tool will suggest the field with high load first, which is first name, and to observe if the effects of the field suggested is good for the system. So the second scenario is similar to the first one, but this time the high load was for the last name with 1,000 user threads, and the low load was for the first name and email queries with 100 user threads each. So it's the same rationale with the first name, but we would like to try for the different field to check if it's not constant or it's not consistently suggesting only first name. And then for our third scenario, there are similar loads for all the fields, and the rationale for this is only for control. So there are 100 user threads each for all the fields, field queries. And then this is only to observe what happens with same load, and the tool should have no big impact to the indexes suggested. Our fourth scenario is the same as one, but we didn't use the suggested index here. So if it suggests first name in scenario one, then we will not use that, and we will instead use we instead used in this project the emails field. Uh, the rationale was also for control. So we would like to check what happens if we did not use the field suggested by our index suggestion tool. So this is to check the effectiveness of our suggestion tool. So for the scenario one, the graph above shows the pre-index response times. So the x-axis is the timestamp of the threads, and the y-axis is the response times of the queries. So when we run our suggestion tool here with a MySQL slow log query enabled, the suggested index was the first name with a field score of 3.946. The other fields are not seen because we filtered out the fields with less than one field score. So when we use the first name as the field index, you can see below in the graph that it's stabilized and it's around 20 seconds of response times as compared to above where it's not stable, and the maximum response times was around 160 and or 140 seconds. So our scenario 2, which is similar to the first one, so it's similar to the above graph of the previous one. And then the suggested index, this is where the user threads are high load for the last name. So the suggested index are as expected, it's for the last name with a field score of 4.158. And then the other fields are also not shown because it's filtered out. So when we use this as the field index, it also showed a good response time for the queries. And then this is for the scenario 3. So this is only a low load scenario, but are all shared with all the field queries. So we see a low query time compared to the last two scenarios. So as expected, again, our suggested index is varying. It's a bit varying, so they're not too far from each other. And this time they're all shown because it's all are above one. And then we just tried to use the suggested index here, which is the last name. And we can see the impact is not that great or not that big. So for our fourth scenario, we use the first scenario similar to the first scenario, but it also suggested the first name. But this time we used the field that was not suggested, which is the email, to just check what will happen to the response times after post indexing. So after that, here we can see the results, which it did not change the response time that much. So it's almost similar peaks around 160, and it's still not that stable as compared to the first scenario. So here are our tabularized results. So for the first scenario, there's an average time of 81.6 with a 22.0 average time post-index response times with a performance increase of 73%. So similar to scenario number 2, we have a 77.7% performance increase. And then, as mentioned, scenario 3 is expected to have a low performance increase since all user threads are running for all the fields equally. And then for our fourth scenario, we can see that it did not impact the system that much. So we have only a 10.5 performance increase. So for our future works, we have suggestions. Since we only check for one field, or we only suggest for one field, we are thinking if it's possible that we can check if there are multiple field index suggestions. And then the other one is live index creations, or where the index suggested or the field suggested will be automatically selected as an index in our MySQL. So there's no need for human intervention or no need to redeploy the MySQL field. And then the last one is real world testing, since we are only using simulations in our project. So summary or the conclusion from the results and from the control experiments, it is apparent that the index suggestion tool was able to provide usable indexes for the application that has multiple queries in a single table. We were able to create a detached tool that can be deployed with an application that is deployed in production. But this needs more real-world testing, as mentioned in the previous slide. So that's it for our project. Thank you for listening.
Thank you for the presentation. We are now open for questions. Okay, we have one question again from Orvin. Interesting topic. This is significant to anybody who has a long-running web application with accumulated data. May I know how the results of your method compare with the results of related literature?
Okay, so our related literature, actually, we found the performance increase from the other projects, but it's not for MySQL. So they didn't have a slow query algorithm or logging system from the MySQL. So instead, they used their own watching tool or watcher tool that checks for the slow query or slow performing fields. So we saw that from their uh, projects, there's also a big increase. I think it's around 90%. And yeah, so it's a bit similar to the other projects, but uh, the main difference is they have experimented on real world applications, and ours did not yet experiment on real life applications. So that's one thing that we can probably improve on. I hope that answered your question, Arvin. Thank you for that question.
So there's a follow-up question from Orvin. Is that found in the paper?
Yep. So we have a review of related literature in our paper. So I think that was mentioned in the paper as well.
Arvin, do you have follow-up questions? Okay. So are there other questions? So there are none. I would like to also ask a question. I just want to know the basis for the equation of the field score, and also the basis for the performance evaluation, the scenarios used for performance evaluation.
Okay, so our field score was based. We initially thought of using only the average response times, but as I mentioned earlier, it was not accurate. So an initial revision in our equation was to use a general weighted average because, for example, there are slow in the first scenario where the first name was the high load. There are logs in the slow queries because the slow queries have many different logs. So there are also high response times from the last name and email, but they are happening less frequently than the first name. So we added a factor of the frequency over the overall logs in the equation. So I I agree with you. I think it could further be improved as a future work. The equation used for field score of our suggestion tool. And then your other question is
The basis also for the scenarios, like, was it the same as in previous literature, the
I know
scenario?
no that we used our own scenarios in this project because we have a simulated application unlike theirs that they have a real world application used.
So we cannot, the results are not comparable. So that's what you're saying, right?
Yeah. Yep. I
Mm.
think so.
Just a follow up regarding the field score. Can we not use the equation that other suggestion tool did or used? I understand that the field score is actually from you, right? From the authors themselves. So I'm curious whether the field score or the score used for the fields proposed in other solutions in existing literature can also be used for your work.
Yep. I think so. I think it can also be used maybe as an additional scenario or as an additional control method for experiment. So maybe for a future scenario, we can also include that.
Okay. Thank you, Alan, for the presentation.
Okay. Thank you. Thank you, Rizal.
Okay. So that was the last presentation. And thus, that concludes the last session of our conference. Thank you again, everyone, for attending. And I hope we all learned a lot. And also thank you to the WCTP 2020 committee for making WCTP still possible despite the pandemic. So for the closing activity, we now turn to Dr. Aurelio Vibar.
Okay, so once again, good evening, and let's give a round of applause, please, to our moderator earlier. So congratulations. Can we give a virtual clap, everybody? Please give a comment, say thank you. Wow, thank you very much. So friends, hello, good evening. It's a beautiful, cool evening here in Cebu City, Philippines, and I am Al Vilbar, and I am your host for our very short closing ceremonies. So first is, okay, thank you. And now, can I request everyone to please go to your chat box and say thank you to all the organizers? And please, can we give a chat, everybody? Let's say salamat, thank you. Thank you especially to the following people. Thank you very much, Meljon, Lo Shong, thank you. And we have, of course, domo arigato gozaimasu to the organizers from the Salle University, Dr. Yami Suarez, Dr. J. Alcaraza, Dr. Rafi Cabredo, and from Osaka University, Professor Masa Numawu, Professor Shinya Nishizaki of Tokyo Tech, and Dr. Takuo Watanabe, and of course, Professor Jaime Caro from the University of the Philippines. So thank you very much. Yes, oh, we have Meljon Cortez, salamat from Zamboanga City. So thank you for the collaboration. And of course, this research workshop, or we call it WCTP, would never be possible without our timekeepers, our moderators. Can we give a round of applause, please, to our moderators? We have Francis Cabarle, Joarin Clemente, Raymond Sison, John Justin Villar, Rich Ann Huayog, and of course, we also have our invited speaker, Professor Tsuyoshi Morata of the Department of Computer Science, Tokyo Institute of Technology. Thank you very much. And can you please, one last request, can you please chat on the chat, can you please tell us where are you now in this part of the world? Can you please tell us your location? Because in this way we want to know how are you. So me, I'm in Cebu. Okay, can I read other people? So June is from Quezon City, Rowena. Alfred is in Rizal. Oy, Rizal. Hope your things are okay there, Alfred. We have from Iligan, Mayong Gabi, Orvin. Jimmy Caro is from Marikina, from Cubao, Palawan, Japan, Yokohama. Greetings, thank you very much. And this is really a good way to connect from each other. Despite all the calamities, we are here to talk about theoretical approaches to computations, practical approaches to computation, and of course, computation to real-world applications. So hopefully, I mean, this is the 10th year, and we're expecting to do further workshops. Now, reminders, everyone. So I understand that you submitted the full paper, and the proceeding will be published in Philippine Computing Journal or Philippine IT Journal. Again, it's Philippine Computing Journal or Philippine IT Journal. These journals are publications of the Computing Society of the Philippines. Now, there's no publication fee for this, only a membership fee of 800 pesos to be a member of the Computing Society of the Philippines. Now, when is the deadline? Your deadline will be on December 7. It should be camera ready and on ACM format. So once again, the deadline is December 7 and it shall be on ACM format, and you shall receive your certificates within 2 weeks. And thank you very much, Alfred, for preparing this. So friends, once again, thank you. And now to give our closing remarks, friends, please help me welcome one of the founders of WCTP. A big hand, please, to Sensei Shinya Nishizaki.
Thank you. Can you hear me?
Yes,
okay.
we can, Shinya.
Okay. So thank you. First of all, to the people of the Philippines, I would like to express my condolences for the damage caused by the typhoon Bamko. I would like to thank the Filipino members of the program committee and all Filipino presenters who prepared for this conference under difficult circumstances. It is an honor to be with you at WCTP 2020. We are happy to see the WCTP held for the 10th time. At the first WCTP, I never imagined that WCTP would be in its 10th year. At the first WCTP, I never imagined that it would be held at Zoom webinar. And not only Zoom, there are a lot of results of computer science that contribute to our life. For example, using genome informatics, we can categorize the new coronavirus into several mutation groups and analyze the infection status. As Professor Murata explained, advanced AI technology is used for drug design for COVID-19. At the first WCTP, I never imagined that such a success would come from the computer science. I believe that in next decade, the development of computer science would make us happy. And I believe that the development of the computer science in Philippines and Japan will lead both people to be happy. What form the WCTP can take next year is unpracticable, of course, but I'm hopeful that it can be held in some form, Zoom webinar or face-to-face conference. See you at the next WCTP. Thank you.
Okay, can we give a virtual clap, please, to Sensei Shinya? Now, as we do it in the Philippines, there must be a photo op to make everybody happy. So can I request everyone to please turn on your camera? And now, so, okay. So Can I count 1, 2, 3, smile? 1, 2, 3, smile. And we have another page, smile. Thank you very much. Domo arigato gozaimasu, and congratulations to all the organizers, the Salle University, Tokyo Tech, Osaka University, and University of the Philippines, Diliman. So, thank you, and what do we have next, Sir Jimmy? Goodbye, leave the meeting.
Yes.
Dinner is ready, okay, in your own place. Okay, so thank you very much.
Bye.
Bye-bye.
Bye. Thank you.
Thank you, everyone.
Thank you.
Thank you very much.
Thank you.
Thank you. Thank you.
And
congratulations.
Thank you.
Everyone, congratulations. Thank you,
Hi,
Chiki.
Jay.
Thank you,
Hi,
Diliman.
Yami.
Bye.
Thank you.
You're
Till the
welcome.
next one.
Yes, this is good. Thanks.
Thank you.
Bye-bye.
Bye-bye.